International Day of Nonviolence. It honors Gandhi's role in India's independence movement and his teachings of nonviolence and peace. For geotechnical engineers, October 2nd is celebrated as Terzaghi Day, honoring the birth of Karl Terzaghi, the father of soil mechanics. Today is also the 100th anniversary of the book Erdbaumechanik, which was written in 1924, got published in 1925 by Karl Terzaghi, which laid the foundation of soil mechanics and geotechnical engineering. Prior to 1924, as Karl Terzaghi writes in the introduction of his book, majority of the decisions in earthwork engineering was primarily based on engineering instinct and experience, which often died with the individual. It was this book who brought science to our profession of earth engineering. Today, we have assembled to celebrate this 100 years of this remarkable journey in geotechnical engineering. This milestone not only honors the pioneer work of Karl Terzaghi, but also recognizes the advancement and contributions made by countless engineers and researchers in the field, both globally and at IIT Delhi. So let's cheers to a century of innovation and progress. Now today, to make our workshop more engaging, I'll be sharing some fascinating historical facts about geotechnical engineering through trivia questions. And there are some exciting prizes who answer them correctly. And I hope everyone refrains from using smartphones or internet to keep it fair and fun for all participants. Our student volunteers are spread throughout the auditorium to get your responses through the microphones. So before we begin our first presentation, let me first give the first trivia question. We all know the father of soil mechanics is Karl Terzaghi. But who is the grandfather of soil mechanics? He is the one who was one of the earliest and the oldest contributors to the field of geotechnical engineering. Can anybody name who is that person? Just give it a guess. If you don't know, probably your guess might be correct. Well, I want one answer. Please don't shout. So who said first? Yes, indeed, yes, it was Charles Coulomb. He actually served as an engineer of the king in Paris and helped in the design and construction of many structures, and that is what led to his involvement with soils. His work in the 18th century laid the groundwork for understanding soil behavior, particularly through his development of the earth pressure theory and the concept of shear strength, which includes both friction and cohesion. So now, coming back on track, without further ado, it is my pleasure to welcome Dr. R.K. Bhandari, Honorary Fellow and former President of the Indian Geotechnical Society. Needless to say, that is a very tall personality with several accolades. He will be presenting on the history of soil mechanics and geotechnical engineering. So please welcome Dr. R.K. Bhandari. Please, sir. You can use this pointer, it will go down.
This will go down.
This will make it down. This will be forward.
Pointer?
This is the pointer. You need a mic if you are moving?
Yeah, here.
Okay.
Is this okay? Good morning. Am I audible to all? Well, let me start with a very good news for all of you. those who are born on 2nd October. I don't know how many of you were born. You know, as you...
Where is my mouse?
क्या हुआ?
Music.
वो
Want to stop.
बंद कर दीजिए इसे.
Yes.
You just heard that Karl Terzaghi was born on 2nd October, and he became father of soil mechanics, modern soil mechanics. Mahatma Gandhi was born on 2nd October. He became father of the nation. And our Lal Bahadur Shastri ji was also born on 2nd October, and he became Prime Minister of India. So it's really a good news for those who were born on 2nd October. All the best to you. Now, let me begin, because the time given to me is just 30 minutes, and I'll try to manage an impossible task in that time. So, did I miss the first one? How do I go back to this? Is it auto moving or what?
No, you are pressing.
Yeah.
This is forward.
This is forward. Bottom one is forward.
Going down.
Oh, I see. Yeah. So I'll be speaking to you on the history of soil mechanics and geotechnical engineering. And you, as you know, I mean, we don't speak German mostly. So it's earthwork mechanics based on the physics of soils. That is what it means for those who are not familiar with it. And I've shown here that the plant which was shown, the seeds which were shown in 1925, they are flowering now, and the whole thing will continue. So what I will be talking to you is not only the history of soil mechanics and geotechnical engineering, but lessons and the way forward. And it's an impossible task, because how to compress all this in a matter of 30 minutes. So you will excuse me if I miss out something, which is natural. Now, 100 years of Terzaghi's Erdbaumechanik. The book itself, which is based on the physics, a major milestone in the field of soil mechanics and geotechnical engineering. It was published in 1925. Name of the publisher you have here, Publishing House in Austria. And then, of course, it was also published in Germany. And we had the English version in 1943, 44. But many other countries also translated this into different languages. Can I operate? This takes time. I think it's very slow. It will be remembered across the globe for International Society of Soil Mechanics and Geotechnical Engineering through its conferences, seminars, focused on Terzaghi. So all over the world. It's not that we are doing it here. And the International Society takes a lead role in that. Then we have American Society of Civil Engineers through various events, lectures, and honor meetings. And I personally attended, many of you might have attended a number of such events that have taken place in the last 100 years. European geotechnical societies, particularly Austria, Germany, which is Terzaghi's homeland, and geotechnical societies organize special events everywhere. Universities around the world, they do it, and Indian Geotechnical Society has instituted a lecture. Geotechnical group of IIT, therefore I congratulate you for thinking of it. In fact, I had attended similar 2 events in IIT Bombay. They had workshops being organized. I don't know whether they are continuing them or not. The event is also celebrated by Austrian Geotechnical Society for geomechanics. And this is the place where it began. You know, Austria is where it began, and back to where it all began. So they are celebrating in that sense. The first event, International Conference on Soil Mechanics and Foundation Engineering, took place in 1936. Terzaghi was president. And then to 21st event, that is International Conference on Soil Mechanics and Geotechnical Engineering, will be held in 2026 in Vienna, Austria. So 2 years later, and which means they have a slogan, where it all began. And so, because Vienna is the birthplace of modern soil mechanics, 1929, the first institute and laboratory of soil mechanics was also established there. So you get the sense that this is a thing which grows with time. And the beauty of the whole thing is where it doesn't die out, there is a momentum, self-generated momentum that sustains. Now, interesting facts. A Century of Soil Mechanics. There's a book like that which was published in 1969. The publisher was Institution of Civil Engineers, London, and 16 classical papers from 1844 to 1946. It carries a bibliography from 1836 to 1948. When I was a student in England at Imperial College, I was privileged to have holding in my hand this thing. So I just remembered when Dr. Ramana asked me to speak on it that there is already a publication like this, A Century of Soil Mechanics. Then there are contributions to soil mechanics, published 3 volumes in 1940, 1953, 1965. The publisher was Boston Society of Civil Engineers. It contains 43 classical papers from 1925 to 1962. So you see there is a wealth of knowledge. Those who are excited about soil mechanics, it's a huge amount of knowledge. We were not so privileged at that time because it was all growing. But now many of these things have grown to a level where we have had due diligence on every matter. So why 100 years? Simple answer is that we want to pay the debt of gratitude to the people. This is one thing which I'll again say, that the gratitude is the fruit of great cultivation and it should grow in our garden. We are often so busy in our own activities that we don't have even time to pay gratitude to those from whom we have inherited this rich legacy. So this is an occasion to do that for all of you. On the pioneering contributions by engineers and builders who did wonders, thriving primarily on empirical observations and experience. Before that, you know, not that they were sitting idle. They created masterpieces and wonders, even in India and elsewhere. But that was purely on the basis of empirical approaches and experiences. Recall experience-based publication. These are all publications, 1792, Hagen 1841, Broch 1848, Stahl 1854, and large number of these. This by no means exhaustive list. So you have all these publications where experience-based approaches are there. So you have a compare and contrast that what a transformational change came when the fundamental principles of soil mechanics was established. So this is where this occasion is also to reflect on that and build taller on the transformational change brought by Terzaghi. So that is the essence of the whole thing, that when occasions like this are there, it's not merely to come and meet and talk a few things about them, but to introspect that how can you build taller on this by taking the good work that has been done. So this whole thing must continue, and here building blocks like principle of effective stress. I'm very sorry to say that, I find that we have forgotten the very foundation. I mean, we do many things, our day-to-day activities are filled with huge amount of hard work, and so I have every praise for that. But the basic foundation on which we are building, we should never forget it. And then the phenomenological concept of shear strength and theory of consolidation. So the new beginning, a robust start in 1936 was made, 1936 is a landmark event in the history of, we may say 1924 and all that, but in 1936, the first International Conference on Soil Mechanics and Foundation Engineering took place in Cambridge, Massachusetts. The New Beginning, where Cooling and Smith, they came out with a paper on shearing resistance of soils. Frolic, came out with consolidation of marine clay deposits. Same year, carrying capacity of piles, improvement methods and consolidation and determination of capillary pressure. Barston's short description, all this you will find. And that is the proceedings of first conference. So in a single conference, so many papers were there, and for shortage of time, I'm not going into it. But I was fascinated when I actually went through the proceedings. And my memory fails me, but that I did in the year 1967. And I had some notes, and some of these things I have taken from my notes, classroom notes, that these are the fascinating things that happened in 1936 itself. Another one, direct measurement of internal water pressure in clay, proceedings of first. Again, international fact, Terzaghi himself said, the proceedings from the first international conference in Cambridge, these are his words, in Massachusetts in 1936, alone contained a greater amount of quantitative information regarding soils and foundation than the entire literature up to 1910. These are the words of Terzaghi. 1948, we had the International Conference on Soil Mechanics and Foundation Engineering started. 1948, International Geotechnical Journal, the Geotechnique, you know, is one of the very prestigious journals we have. It started in 1948 by British Geotechnical Society. 1948, Indian Society of Soil Mechanics and Foundation Engineering was established with Dr. A.N. Khosla as the president and N.D. Gulati as the honorary secretary. And 1960, 1975, 2007, Indian Society of Soil Mechanics and Foundation Engineering hosted the first, the fifth, and the 13th Asian Region Conference. 1994, India hosted 13th International Conference on Soil Mechanics Foundation Engineering in New Delhi, for which bid was won in 1990. And myself and Dr. Shashi Gulati, we feel privileged to have the opportunity to have gone to Rio de Janeiro to bid for the conference, and we got it here. There's a context which I'll come to, why I'm mentioning this. And here, in 1985, R.P. Kulkarni, he came out with Indian Soil Mechanics Ancient to Medieval Period, Indian Contribution to Geotechnical Engineering, a commemorative volume released at the 11th International Conference on Soil Mechanics Foundation Engineering in San Francisco in August. So we have to learn from this, that whereas we talk about 100 years of this, what happens in this country where we are working and what kind of contributions have come from beginning. So you have the opportunity to pay gratitude, to reflect on the past work, and then contribute towards it for future. Now, Charles Augustine, this was a puzzle given to you as 1736 to 1806. He was game changer. And why I say this is when we talk about 100 years, we should not look at it in a silo, you know. This all based on the work of others. Terzaghi himself said that in 1936 it had double the knowledge was there, but it's a continuum. And we don't belittle the experiences and the kind of empirical ways in which the designs were made, because they also fed into our imagination, which led to this. So this was the Earth pressure theory. And then, of course, you have Rankine. You are all connected with soil mechanics. I don't have to go into the details of it. But then, you know, these are the ones where pioneering work was done long time back. And so, why I mention this is some of these concepts are alive even today. So it's not that they are obsolete. You get a lot of insights. You see how the progress took place and so on. So it's a kind of work that lives forever. More, 1871 gave the graphical representation of a state of stress, the Mohr circle. You are very familiar with it. Busenus, the theory of stress distribution. Prandtl proposed theory of plastic equilibrium. Gelman, field and laboratory test methods, 1930. You are talking about this development of methods, and dozens of these have been developed. But do realize that at that time when they're starting from scratch, there were methods developed, and a very fascinating one. And sometimes I find that the decay in our imagination, because those methods that I saw working even in 1967 and all that, today I don't find that kind of care of detail that is there. Influence of artesian wells and all that, those who are not very familiar with the principle of effective stress will find that many of the projects would have been misguided totally had the concept of principal stress would not be there. Otto Mohr, he left his footprints, expanded the Coulomb's work in 1773 to introduce the concept of Mohr circle. Fellinius, W. 1926, you know of him by Fellinius' method of, but if you talk to the people and read his works on earthwork stability calculations, it's fantastic. Even at that time, the kind of imagination that he had, cylindrical safe surfaces. And Gilboy, Soil Mechanics Research Proceedings, ASC, 1931. So they were talking about soil mechanics research in 1931. Again, you have the fundamental soil dynamics, mass dynamics, 1931, 34, 37. These are publications. And there are only to give you some example, there are others also. Rendulic, relation between void ratio and effective principal stress. This was the first fascinating paper that I happened to read when I was inducted into this fundamentals of soil mechanics. And I highly recommend that while we respect all the work that done by Terzaghi, Bishop and others, we should go into this proceedings of the first international conference where Rendulic presented his ideas. Haefele, similarly for creep problems and for when we talk about Skempton's residual strength and all that, you find the roots of that imagination in Haefele's work there. Rosenquist, Bishop A.W., the use of slip surface in stability analysis. Golder, state of art on floating foundation. So you see that many of these things that we are talking about in a refined way, we don't even remember where the roots lie. Atterberg limits. Now here again, I picked this because everybody talks about liquid limit, plastic limit, plasticity index and all that. But imagine 1911, where are we? Now we are 2024. He talked about Atterberg's limits, gave us the Atterberg limits. And in 1984, of course, the ASTM, all the design codes and practices and guidelines, they included this method of Atterberg's limits. ASTM came out with this, International Society of Soil Mechanics. Bureau of Standards also had that. And IES came out with this standard in 1985, methods of test for soils determination. And that's what you are using now. So you see where it came from and how transformational changes it has gone through over a period of time. I would like to tell you this, that this is not just a mention of the applications that have changed this. I'm only familiar with some of the work that I did. And when I found that all these things where Skempton was the first one who took this as a global exercise. He looked at the clays across the globe. When he talked about organic soils, he talked about this. I actually helped him in doing some tests on that. All the undrained shear strength, effective overburden pressure connected with the plasticity index across the globe. It's not just doing some tests here and there. And then all these formulations came. Now here, you see Cox 1970, Skempton 1957, and then for Indian clays, at that time I was fascinated on that and we did that. So all these are standard publications that you see. Now why I mention this is that back of the envelope calculations are also necessary because you know best things happen only in paradise. If you think that in a project you will only start thinking when everything is on your table and all the tests are done and all that, you are totally mistaken. The culture that I have seen is that whatever little information you have, try to keep learning. Don't close your mind, it should be open mind and all that. And then these relationships help quite a lot. So whether it's Cochin, Visakhapatnam and all that, I mentioning this because such work is totally forgotten. When new projects I come across, they don't know about what happened. They start doing all over again. They get the data, I start designing and don't take advantage of the published material because they are not aware of it. So this is just, I've given the references also. The two of these references are there. Now, Terzaghi, game changer, and the father of modern soil mechanics. So we start with ABC. That is fundamentally speaking, you know, when we talk about this, they're all rooted in effective stress principles. So that is there. Best picks. Now, I don't have to go into this because I think this you will all be knowing already, many of these, but these are 50 years of soil exploration, proceedings in third conference. Now, in 1953, he was talking of 50 years of exploration. So you can imagine that what we are talking about is in continuum, actually. The whole thing is a continuum. Then this is the very important one. Consultants, clients, and contractors. General Boston Society came out with in 1958. Now, this is where we interface with the contractors, consultants, policymakers, and all that. What I have found is our geotechnical engineers in this country, including myself, actually, we used to have a feeling that we work in silos. There's no contact with the other, no interface with even policymakers or where decisions are being made or bureaucrats and things like that. So soil mechanics is soil mechanics, of course, where bureaucrats would not understand, politicians, policymakers will not understand. But you have to understand that what really matters to get the things through and how convincing your arguments are to be able to do the right thing. But what we have done is that we have learned to compromise at our end rather than educating others for right decision making. So this is something where a lot to learn. He was talking already about critical height of slopes in 1936, stability of slope, natural clay, shearing resistance of saturated soils, soil mechanics, a new chapter in the engineering science, 1939, Journal of Institution of Civil Engineers, then 41, disturbed clay sampler and all that. Now, you see how much of wealth of knowledge was there at that time, and they were already thinking about it. So, how much have we added? That's the question. How much have we understood it? How much we have imbibed and carried forward? How much we have learned from the mistakes made, experience gained, and so on. It's all very vital. Terzaghi and Peck. Now, I come across many publications, but I would like to underscore a few which are like Bible to me. I mean, they were written long time back, but when you read, you get educated even today, much more than anything else. Taylor, for example, 1906 and 65, Fundamental Soil Mechanics. I can tell you that I have so far not read any book which is so beautifully written and so convincingly stated as this book. Peck, 1912 to 2008, Observational Method. We have forgotten completely, which is a highly innovative approach, and I'll talk about it later. Skempton, coefficients A and B, pore pressure and effective stress. Bishop. So these are all unforgettable, rich inheritances. evergreen, you know. Every library should have it. I don't know whether there is a fact-check kind of approach in IITs and other places where we have these things, because we are so much saddled with the modern approaches, modern projects, and kind of input of information that we get from influx of information from all directions, that we tend to forget that these are the ones where they are going to influence your thinking even today. If you read 10 pages of some of these, they will be equal to 10,000 pages of other stuff that you will be reading somewhere. So I highly recommend, please have a look at these closely. Now, my personal gratitude, because I was really, I am grateful to God and to Ramanaji, where is he, that he invited me, because this gives me a chance of paying my personal debt of gratitude to some of these wizards, our professional giants with whom I had the opportunity to work with and know personally about. A.W. Skempton, A.W. Bishop. No, Nick Ambrasis, I don't know how many of you will know him. He was a great seismologist and earthquake engineer at Imperial College. Norbert Morgenstern, slope stability, everybody would know him. John Hutchinson, I worked directly with him. Then R.B. Pack used to visit us quite frequently. Barham also. And R.E. Gibson, yes. And Fukuoka. So the slide could take only these, but these are the ones who influenced my life a great deal, and I take the opportunity to pay my personal debt of gratitude to all of them. Arthur Casagrande, he was on my wish list, but I never could have time to meet him. He only once came, and I missed the chance. But you know, Terzaghi discussed with Casagrande his book that he has written. Very few people will know that before publication, the gentleman who worked very hard with Terzaghi was Casagrande. So impressed was Terzaghi that he asked Casagrande to serve as his research assistant on a consulting project for the US Bureau of Public Roads. During these exciting 2 years, Casagrande focused on soil classification, shear testing, and frost action in soils. In 1936, he organized the first international conference in soil mechanics. You know that, how much that appeared in that conference. It's phenomenal. I don't think that any other conferences, they have grown in volume, number of volumes, number of pages, number of papers, but content, the density of information that is there. Served as the president of the International Society in 1961, from 61 to 65. He is a recipient of Karl Terzaghi Award presented by the American Society of Civil Engineers. And he is a violin prodigy. As a child, Terzaghi was his fellow countryman, mentor, and colleague. So, great thing, and this country should be grateful to him also, because when we started talking about measurement of pore pressures here in this country, Casagrande open standpipe piezometers, Vermaji used to do that. Then we came out with the Bishop twin piezometers, then strain gauge electrical piezometers, then vibrating wire piezometers. The whole science helped this country grow in that direction. So this is one thing where we remember him. Best picks of Casagrande again, because I was told that some students would be there, and for their benefit I have brought in here research in Atterberg's limits, that what Casagrande talked about, you know. Immediately he picked a structure of clay and importance, the determination of pre-consolidation load, shear failure in anisotropic materials, application of soil mechanics in designing building foundations. So here is the one where you see a lot of concepts that you now find they were there in 1944. Piezometers, this is one where personally I benefited the maximum from this work. And Casagrande also came out with electroosmosis, and that is in the proceedings of the second International Conference on Soil Mechanics and Geotechnical Engineering. Karl Terzaghi, his life and achievements from theory to practice. In 1960, he wrote, So those of you who are keen to know more about Terzaghi, you have to go through some of these publications by those who worked with Terzaghi, and they have written this. And across the globe you will find this. So this is not an easy task. It could be a big job for anybody to get into this, but today's age when information flows so swiftly across the globe, it should not be very difficult. You will be able to find that out. Role of calculated risk. This is what I want to say. I talked about observational method that Peck said, and we'll talk more about it. Second is the calculated risk. It's not high science in that sense, a rocket science or something. It's where engineering judgment matters, and therefore calculated risks come in. Now, how do we deal with calculated risk these days? Not by imagination, not by analysis, not by diligence, by brute force of technology. We say that we can deal with anything, you know. I mean, worst come to worst, we remove the mountain as such. Why do we study soil, shear zone, slope and all that? We'll see that it doesn't exist, and we get the whole thing. So this is where I say that the role of calculated risk and the engineering part. If it dies out, what is left in it? And then we can hand it over to someone else, I mean, this subject, and they will do better perhaps. So Terzaghi on landslide. Why I took it is because personally in my career I got affected, immensely influenced by it, and I thought that I'll be able to give a couple of things to you which from my own experience would benefit. Let's consider pioneering contribution in landslide studies, and here I've written principal effective stress. Now 99% of the people I have worked with and those who are working in this area, they don't know what is the principal effective stress, and they don't care to know what it is. So you can know my pain of that I have been coexisting and working with some of these people who only know how to fix problems. And whether they succeed in that, I don't know. Another thing is landslide can be predicted, prevented and controlled. Terzaghi has written the whole thing about it. But I will say the statements coming from experts in this country where they say, oh, this we can't predict, this we can't prevent, this is climate change, this is this extreme weather event, high rainfall, and all those things, they are brought in. But there is no sincere attempt to understand the mechanism and then predict it. So this is, I am quoting Terzaghi, that can prevent it and control. Landslide occur because of interplay of multitude of causative factors on a geological time scale. Do not confuse it with the last straw that usually breaks the camel's back. Bishop used this sentence in our teaching. He used to say, rainfall. Everybody talks about, oh, so much of heavy rain took place, and therefore last 3 days it was raining, 15 days is a Met report, and so on, and they forget multitude of other factors. And their interplay, which is at the geological time scale is talking about, we don't talk about time scale of 2 years or 3 years even. And history is not our concern at all. Scientific landslide investigation is key to the understanding of landslide. There are of great variety, they are bewildering variety. And therefore, unless you investigate and do this and you bracket all landslides as one family, closely knit and identical to one another, that would be a very big mistake. So this is what Terzaghi's message was. It all started with Swedish method of slices. And in 1916, the circular surface was established by Peterson. Then Hultin developed analytical method, and Felinius, what I mentioned to you and what textbooks convey, is extended the method of soils with both cohesion and internal friction. So it is also having its own history. Advances in slope stability, A.W. Bishop, Jambu, Morgenstern and Price. So these are the ones where you have the design softwares and all this. And let me tell you that Bishop, when he did that, at that time there were no calculators, no computers. 47 pages of handwritten calculations he had made for his thesis. So at that time, for validation, even Bishop's simplified method so much of hard work was done on that. And now with all the modern technologies, people don't even care that whose method is it. They go to a software, put some input, there's this output, and they get the printout, and that's the beautiful thing. Then everybody has applause that yes, calculations done. But what is the process? The devil is in the detail. How did you start with? What are the kind of parameters? And all this. So you get a lot of messaging from this that I've listed here. Skempton. In 1948, phi is equal to 0 stability analysis method. You know, and you find number of articles on this, number of PhDs done on that. Pore pressure coefficients, 1954, 1960, Terzaghi's discovery of effective stress in theory to practice in soil mechanics. So he had reflections on that. It's not that what Terzaghi did, everybody accepted it, that they added value to it all along. Then fourth Rankin lecture, long-term stability of clay slopes. It's a beautiful piece of work. Those who would like, and it influenced the Mangla Dam. You know, all the designs had to be changed because he came out with the shear strength on the slip surfaces, slide boundaries, dramatic reduction of shear strength post-peak, and so on. And so that kind of concept came in and changed the whole concept of design of railways, even in England, stiff fissured clays. Stability of cuttings in brown London clay, 9th lecture. Now this I must say, because myself, Dr. Shamsher Prakash, we were certainly present, but maybe a couple of others were present. It was in Tokyo. And why I mention this is Skempton had the humility to say that he misreported something in his Rankin lecture. You know, he was talking about the peak and the residual strength, and then at that time he said, cohesion intercept 0, angle of friction, he was mentioning. In Tokyo, he said, is the cohesion intercept. And then he talked about RU value. I am not going into those details, and that takes some time to dissipate. So all that concept, and in that he got a standing ovation, more or less. Everybody was so appreciative. He apologized to the audience that he should not have done that at that time. He should have worked a little more on this. Yeah, so it is here. You see, this was published, R sub U, and that's why he came out with the age of cuttings and so on, all the concepts. And then this is not just one or two tests. I can tell you that one sample collection will take 3 days, and to bring it to the laboratory and test will take 9 to 10 days. I'm witness to it. And then how they are done and how temperatures are controlled and things like that. So this is something which hardly people will believe that so much is required to do this. And here I have written here, Shamsher Prakash, and we were there, and we found that is a grace of candid confession. Now this I would recommend to all of you. In fact, I do it myself, that we, in a hurry of thing or whatever reasons, we come out with some publications where we have misreported or knowingly or unknowingly or whatever it is. We do a lot of damage these days. People just go on referring, and particularly comes from very senior professionals, then they are not questioned. But we have to have this approach added to our way of working. Now, India got the art of dealing with slick and sided slip surface. In fact, you know, when in 70s, when I found that most of the places, nobody was bothering about this. We didn't have technology for sampling, etc. And so even in areas in Uttarakhand, where we have a good seat of learning in IIT Roorkee and all that, there were hardly any attention being paid to this, so we try to bring about, and here I will pay tribute to my colleagues, Professor Yudhvir, Professor Nitin Som, and myself. We three used to team up and mobilize our influence to influence others in taking up that. So, and unfortunately, Nitin Som is no more now. India's first geotechnical digital systems, if somebody is from AMIL would know, of undisturbed sampling was established in 1980 in CBRI. Ground penetrating radar, vibrating wire piezometer, and Wilson slope indicator, all of these things were introduced to bring sanity to the way we work, the credibility to what we do. We sometimes have no opportunity to go into the details, and we see end results. But end results cannot be credible if your process has flaws here and there. So, importance of stress deformation and history of soil was brought into this landslide studies, and then we made use of, in India, we made use of all these very extensively, just want to say, and Rankine lectures, 1966 Rankine lecture. These are all very pioneering contributions and valid even today. You know, they didn't say anything which you would not accept even today. So it's a beauty that you should go through it. Progressive failure. I will go fast because I have limited time. I just introduced that, and I'll mention Henkel here because he is the one who came to IIT and established triaxial testing. He is the one who actually, first myself and Yudhvir met him at IIT Bombay when I was doing my master's there. And then Yudhvir also went to Cornell to do his PhD, and Henkel was associated. And then, of course, he had linked with the Imperial College, so I used to meet him very frequently. And his book, actually, Triaxial Testing, is what influenced most of the people. Then in this country, you know, we early stages, when Shashi Gulati was here and he did some event, these cuttings and embankments. There was no difference. Geotechnical engineers, whether cutting, embankment, half embankment and all that kind of thing. So I came out with a paper which was published there, and I can tell you that this helped a great deal at that time. The designers took it up and all that. I don't know. Now I'm not very familiar what the practice is now. Bishop turned several PhDs with the in-depth research on effective stress. He introduced ring shear apparatus. And there are several PhDs on that. So all these things were then tested on the ring shear apparatus. He was very particular about the use of field measurements, piezometric measurements. And then not that any piezometer can be put anywhere, you know, where you have partially saturated soil, high-end air entry value piezometers and quick reading piezometers and all that. So Morgenstern then helped us. He used to come to Central Soil Mechanics and Material Testing Laboratory, and where our friend, late VM, was there. And I also used to take him to the sites in Uttarakhand to talk about him. And then he told me that most of what we are doing actually needs review. Because what happens that in our case, in stability, we are removing huge mass of rock, unmindful of the stress relief concepts that we have. What is the long range impact of it? We don't take anisotropy into account. We don't take the changes in the piezometric pressures. We don't take discontinuities into account, and then take that as simple slopes and do the design in our DPRs. So a note was prepared for Government of India, and at that time some decisions were taken. Now I come to this magic of observational method. This was the Rankine lecture in 1969 where I met Peck first. And you know, this diagram that you see here is a Kennedy Causeway Saturn rocket transport system. So you see N values, you are familiar with this. Now, when these N values were given, this kind of profile was given to many, many experts, they say that, well, this cannot take the equipment, heavy equipment, and therefore they were suggesting that equipment should be placed on piles or something. Now, it's the first time Peck came out with the concept of observation method. And you know, not a single pile were necessary. He simply made a load of earth and took the heavy equipment, and he calculated precisely how much it is going to settle before the equipment passes through. So you see very, very interesting analysis of this. And that is where there are a number of projects where PEC was associated. He made use of observational method to deal with uncertainties rather than taking dramatic action of putting, even for temporary purposes, foundations. Here it is a practice that if you have to carry something heavy and the route on which you carry is not able to take that, then you put some expensive foundation. But this is not what PEC did. Now, Chandrakant Desai, I must mention this because skirted foundations and all that. And why I mention this is that this is a message for my colleagues that at that time there was culture. We used to invite many of these experts, world-class experts, to come and stay with us for 2 months, 3 months. Now there is a culture, they come and deliver lecture and go away. But at that time, Chandrakant Desai also stayed, and he is expert in FEM, and entire study of skirted foundation and all that at CBRI was developed when he was there, and we trained the people. Then on projects we made use of it. So the only message here is that we have enormous opportunity as India, as a country. So many of our best experts work, but I have not seen that culture which was provided by the top 10, that we invite them and they stay and work with our people. Same thing, Scott, I mentioned before this lecture started, that we invited him. He led studies on lunar soil and all that, and visited CBRI, contributed state-of-the-art on slope stability studies, an international event that was there in 1980. So all these people, they have benefited us, and we have to have the gratitude for them. Then, of course, there are some innovative and mind-boggling things that you find in 100 years of this, where this world's deepest hole, drilling started in 1970, abandoned in 89, and project closed in 2005, 12 kilometers of this. So what I'm saying is that let us get inspiration from all this, how they did, what happened. Now again, I come to Nick Embraces. He was pioneering contribution in seismology, earthquake engineering, and I mentioned this in limited context of fault zones, shear zones, conjugate stresses, and so on. And one message that what happens on a mega scale when you are looking from space or from aircraft or something, same thing happens when you look at the microscope. To the nature. There's so much of uniformity law of nature that now you see here from aeroplane the fault zones and all that in an earthquake. This is a picture which was analyzed, and now you see it. I in my experiments did something. Same I replicated on the slope. These are actual studies there, and on the right hand side you see John Hutchinson. In his own handwriting, he was explaining to me as to how these will develop and all that. So the idea here is that you have to really be so intimate with the soils and features that occur that you begin to speak to them in the same way as this there. So Hutchinson did the pioneering contribution here. He started with simply classification, etc., and different types of surfaces. But then here, you know, one of the thing I found was, fresh from IIT here, I thought that I knew quite a lot. He left me at the site for 3 days and said that you make a plan for soil investigation. And I made an elaborate plan showing what I'm going to do there. And ultimately, you know, time doesn't permit me to say this, but it so happened that that report that was of no use, because then he spent 1 day with me and he exposed all these slip surfaces and everything. He had a hammer with him and gum boots and hammer, and we went round and all that. And then he asked me how many boreholes you need, how many things, and I was amazed that as geotechnical engineers, how much we miss by taking recourse to the kind of course which prescribes certain things, and we mechanically do it. And then, of course, sorry. I'll come to this. This is Professor Derek Petley, perfected the art of sampling of shear zones. Now, this art is not easy by any means. And why I put this here is that Professor Derek Petley taught me this, and it used to take sometimes 3 days to collect one sample. Then transport it, then how do you use it and all that. And that one sample will be great value than 400 samples that you might shift and do something about it. So that is where the power of sampling, and of course then microscopic tests and all that. Now this I will spend half a minute in explaining to you this. This is a fundamental explanation of mechanism of slides where in situ measurement of pore pressures were made. And then we found that when landslides come, they override the lower slopes. And in the process, they create excess hydrostatic pressures which drive that again. So that was actually my PhD thesis. We proved that indeed there are artesian pressures which are created in the rear boundary. So all these measurements, etc., are in a published paper in the Geotechnical, you can refer, in 1971. And that, of course, why I mentioned this is Malingam slide in India 2014. And exactly what happened there and what I studied applied to this. So these are actually drone pictures. We took also ground surveys on behalf of the academy. We did this in August 2014. And then when I analyzed this, there was a loading from the rear car and this occurred. So what I'm saying is that all these slides which are taking place, actually we have to have patience to understand them. And once we understand them, it will be possible to do this. So this work actually got John Hutchinson Once Medal in December, and me also. He got it in 2004, I got it in 2012 for the extension of work that we did on that. But this is why I mentioned this is that little things of observation has a profound practical influence. Then, of course, you had the Harry Bolton Seed, Kenji Ishihara. They have come here. I mentioned this because they were intimately involved with this, and they came here and did a lot here. And that helped us, this Professor Yudhvir here, when Gujarat earthquake took place and seismic reports came. I don't go into the details of it. They give big boost to the calculations and the microgeological details, etc., that you will see. That's one. This is all published material, so you can find the signatures. Now, currently, we face rapidly disturbing trends and the beginning of the decay of soil mechanics. That is when I'll spend little time on this. Now, from science-based approach, we have a sledgehammer approach. Here, in the science-based approach, we have scientific investigations, geomorphology. We all talk about beautiful things in soil mechanics, including effective stress and all that, culture of disturbed sampling, stress path testing and all that. So that is the route to humility. Now we have come to a kind of arrogance that we don't need all that. We have the ways of handling it, and so we have a sledgehammer approach. This is, I have witnessed in real some projects. So future, past and present we'll talk about. Say, where is the soil mechanics we have been taught all these decades? And he says, consult ChatGPT, I'm in a hurry. So this is the state of affairs that we have. The situation has arisen because of the unprecedented power of big data. This is a great advantage. We in our time did not have, I was working on facet calculator and electronic calculator and all that. The computers, etc., came much later. So big data, we have intoxicated with the power to manage extremely large data, computation analysis to reveal patterns, trends, associations. So why do we need to be very careful about it? We order this kind of thing, you know. And so earlier we say that, how can I find a needle in a haystack? Now you say that you create a haystack and I'll find the needle. That's the approach, different. So we have big data, volume, variety and veracity. So it's both challenge and opportunity. I don't devalue this. It's a huge importance to deal with big data, but how do you use it is important. So in this one now, I'll come back to this example which I have, actually I was a member of 2 committees which examined these major projects, and there is no geomorphology, no engineering geology, no hydrogeology, no geotechnology, no dilatancy effect. These mountains were removed, retaining walls were built, drainage were created and so on. So this is where sorry state of affairs, and we have to deal with it. And why this is happening is that in site investigation, we take recourse to multiple tests. Now, depending upon who is your contractor, he will do some tests, and you have a wide choice. Why the insensitivity to intra and inter method variations, invasive methods and non-invasive methods? No distinction. No, we don't discuss. I have at least been part of committees. We don't discuss which tests and all that. So long as why we continue to be mindless about use of SPT? Then we have disregard for the benefits of multiple choices. They were generated by our forefathers for our benefit, and we have just thrown it maybe with bathwater. Why we pay blind to the severe limitations of different field and laboratory tests? Have we ever asked the question why they do this kind of thing? And then ultimately, the beauty is that we have all those junk and then we have a fine curve. Why get lured by the magic of the best fit? When the best fit is there, everything is forgotten. Yes, we have that equation, modeling, things like that, and things work on. So let us introspect. It is never too late to act. The world is your exercise book, the pages on which you do your sums. It is not reality, although you can wish reality there if you wish. You are also free to write nonsense or lies or tear the pages. This was not me, it is Richard Bach who said this. So let us be very careful when we write something. We influence not our career, which is a very narrow way of looking at it, but posterity and generations, all that. So a new beginning. I'll go very fast now to finish in time. There's no silver bullet. Don't search for it. There is no such silver bullet. As you see that you will have some kind of technology come and fix the problem. Think to scale. Oh, sorry. Well, anyway. And always have what is vital, what is essential, what is desirable. Distinguish between them. I have seen in many meetings, 1 hour meeting, 36 or 40 minutes are spent on what is desirable. And in the end, while the meeting is concluding with a talk about essentials and vitals, So this is where we have to list out and be sensible about it. Then some of us are very good at theory. Some are very good at practice. Now we have to find a bridge between the two. How we do it is our challenge. Now, insist on stitch in time. I don't mind when somewhere I go, they say, how can I do all this? This will happen tomorrow or somebody will die. Stitch in time is important. But at the same time, nature-friendly solutions should be brought in. And sustainability. These are right now only in speeches, but we have to attain them. I'll give quickly an example. There was a century-old landslide. I was associated, that was in Sri Lanka. And a railway line was affected. So massive landslide occurred. Everything was dislodged. And here, out-of-box solutions were to be found. Professor Hutchinson, you see in my group there, coming. So land was thoroughly investigated. Global tenders were invited, while rejecting all the bids on the ground of unfriendly nature. An alternative package of nature-friendly solution was developed. It being unconventional created a vertical split between the bidding parties and experts. Professor Hutchinson, Dr. Derek Petley and Robin Chaudhary were invited by me to stand by on my side, and then we won over and we implemented the project. I'll tell you what it was. A package of control measure was implemented and landslide was permanently fixed. Now this was the one that we, by methodical approaches, this is after a lot of investigation we came out with how the slide was taking place. You say multiple slide boundaries. It's one of the finest example of out-of-box solution. And once we came to know the state-of-art investigation landslide, we had the mapping of multiple slip surfaces, instrumentation and field monitoring, then we had option A, B and C. Now, the global bids were on sledgehammer kind of thing. They didn't report that. So we came out with this. Then one of the contractor I won't mention from India, leading contractor, he had this package put in that he said he will put the railway line on the piles, and he will have anchors and all those things, and a few drains he built there. So this was one solution: pile, platform, deep anchors, stone columns, drainage. Then there are some others. Time is not very, but 5, 6, all proposals were like this, that will do it. But whereas the problem was of drainage. You know, this is extremely poor drainage. So I came out with a solution that no retaining wall, no piles, nothing, only drainage. And then we came out with the proposal, and this was there, that deep drains, the 1 mile, 2 kilometers deep drains, and wells, all kinds of drains were designed, and then these were implemented. The drilling machine, directional drilling was used, and then the slide was brought under control. And you know, 10 years later, I used to visit it every year, and there's absolutely no problem at all. So here is an example where no drainage, no retaining walls, nothing, but it was done. Not that every problem will be like this. But what I am saying is, nature-friendly solution should be favored. So now what happens in our country, we have to re-establish the in-depth studies on ground exposure. When such exposures are there, still they would do boreholes. You know, when metro was under construction here, so many exposures were there, nobody mapped, and 200 boreholes were done with DST funded thing. So we have a state-of-the-art report. 1979, Date and I did that, and there was a international event in Singapore where this was published. Similarly, we have to restore to the nature-friendly solutions. Now, in England, there is an example where such a beautiful mountain system was to be established. So if you cover it up, if you put anchors and things like that, all the beauty is gone. And here you have to find nature-friendly solutions. Then about the study the capacities. So I already mentioned that we have to have indigenous capacity, which was already existing. Golden period was 1980 to 89. In a single lab, in fact, in my IGS lecture in 1987, also I mentioned some of these, and they were flourishing at that time. But nothing exists now. Everything is being subcontracted. Laboratories are subcontracting all the work. They are not doing it. So in my lab, when we did that, there's a Professor Jay Krishna. He's our Dick Perry, who came. And many people, you know, I don't even remember. Hundreds of people came, and we demonstrated to them that this could be done. And in India, actually, we did that. But everything seemed to be wound up now, and we must restart at least to create some centers. And when we did that kind of work, Masami Fukuo was so fascinated that at the Moscow airport, we were both there for 8 hours, and he translated my paper into Japanese. And that was the first paper that I got published. He was so fascinated that kind of thing. So that is the kind of devotion that is there. Then the idea of ground penetrating radar came in for Taj Mahal and all that. And, you know, here Leggett came. Shamsher Prakash organized an event in Delhi. I don't remember which event was that. And Leggett was talking about Taj Mahal and its foundation and all that. So Dr. Mitra, who was FRS and Director General CSIR, once he told me that, why don't you find out what it is? Why this controversy? So he granted a ground penetrating radar, and we made use of it in Taj Mahal. So this is how the transformational change come, that if we insist and try to take it, this happens. Reflections, field instrumentation, we started in 1980 and all that. I don't go into this. I myself, in every event, I made these presentations in 1989 also. And I think I highly recommend that observational method, calculated risk in geotechnical engineering and instrumentation can solve quite a lot of your problem. And at that time, this Professor Mehra, director of CRRI, he expected that, and then a lot of things were started. So I finally come to this, that this kid glove approach of tampering with the problem or sledgehammer approach, give it up. There should be right size of hammer for right side of nut, and that is where you have to work on that. International inherent of rich legacy. Now we have we are to be proud that we have inherited rich legacy. and we must add value to it. So how can we do that? Top 10, I'll give you the concept, but in New Delhi we had 13 international conference. Now in 2030, let us have 22nd international conference, here. So if you start working now, and the advantage of having an international conference for younger generation is fabulous. At least I remember 30 to 40 of the students at that time, they had the opportunities to go and work with different stalwarts, different parts of the world. But I am sorry, unfortunately this is not happening. So I would say that now this 2026 is in Vienna, and in 2030 we should work, IGS should work for that event. Maybe IIT Delhi can take lead. The International Symposium Landslide, this was organized by me in 1980. When number of these people came, all these people are connected with us for decades. They proved to be game changer. The first major Indian initiative was taken, and then it has a snowballing effect. We gave 4-year periodicity. So till now it's sustaining, 80, 84, 88, and all that. So this is where I have suggested to the President that bid for ISL 2028. We had in New Delhi in 1980, Canada 84, Switzerland 88. Both I had attended there, and these are all the various events that have taken place. So if we can work for this, then you will find that that also will give a big boost to our activities here, and our young people who do not have the opportunity to go abroad will get a good exposure of this. Takeaway. Finally, I conclude by saying that road of knowledge built by successive generations for journeys with milestones and not destination. There is no summit of human excellence. Accumulated knowledge increases in value at compound interest. The fact is that knowledge accelerates its own advance. Imagination is more important than knowledge. We cannot solve the problems with the same level of thinking which created them in the first place. We need to breed the culture of truth-seeking, nature-friendly approaches in problem-solving rather than get lured by the glamour of and magic of big data and growing might of technology. In the end, we only regret the chances we did not take. So these may look general, but I can tell you I have derived this. I have a little notebook I keep writing when I read something, what inspiration I get from that. These are all built for that. If a man does not know what port he is steering, no wind is direction is favorable to him. The golden rule is in soil mechanics, there are no golden rules. To guess in soil mechanics is a self-goal when done without credible data and without due diligence. Facts about complexities of ground do not cease to exist just because they get ignored. Never express yourself more clearly than you are able to think. Nothing exists unless it's measured. The finest plans are always ruined by littleness of self-styled experts in soil mechanics, drugged by intoxicating power of modern technology. No grand idea was ever born in conference, but a lot of foolish ideas have died. Speed up change. All great changes are preceded by chaos. So if you see the chaos, don't get worried. This is a positive thing that now there is you can take on from there. Progress against the storm of technology is impossible to contain without our collective resolve to change. And those of us who cannot change our minds just because we hold degrees, awards, years of experience, and lucrative jobs cannot change anything. Change will not come if we wait for some other person or some other time. We are the ones we have been waiting for. We are the change that we seek. That's what Barack Obama said. It doesn't matter how strong our opinions are. If you don't use your power of positive change, you are indeed part of the problem and not part of the solution. Finally, there is my last slide. Please forgive me. It is well nigh impossible to do justice with 100-year-long history of soil mechanics in 30 minutes. I have undertaken seemingly impossible task as a heaven-sent opportunity to pay my debt of gratitude to the pioneers who laid the strong foundation of soil mechanics. Despite having only primitive tools, they achieved remarkable feats Now, with the unparalleled advancements in soil mechanics and technology at our disposal, it is our duty to honor and uphold the core scientific principles they have passed on to us. Thank you very much.
Now I would like to call Professor Ramanna to hand over a small memento as a token of appreciation for gracing this occasion. There. So now we will move forward with our next session, which will talk on the history of geotechnical engineering at IIT Delhi. But before we call upon the speakers, I just want to point a small note regarding the history. Karl Terzaghi died in 1963, and one of the projects that he was doing before his death was he was designing the Mission Dam in British Columbia, which is in Canada. Now, as Arthur Casagrande says, this project demanded an extensive use of Terzaghi's experience and professional knowledge that it was none other like in those times compared to other consulting assignments. And it was after this dam was constructed around 1964. In 1965, this Mission Dam was named as Terzaghi Dam. And it was around this period the geotechnical engineering got introduced at IIT Delhi. So with that, I would like to now call upon our section coordinator, Professor Ayuthi Raman, to talk about the milestones of geotechnical engineering at IIT Delhi. This is down.
Dr. R.K. Bandari, renowned expert in the geotechnical engineering, and invited guests, my dear colleagues, and my dear students. Very good morning to all of you. And in today's talk, I'll be giving the glimpses of milestone on the geotechnical engineering, how it evolved at IIT Delhi. We know that IIT Delhi was started in 1961, initially as College of Engineering and Technology, and which was renamed as IIT Delhi in 1963. And even before the first batch graduated in 1966, in the year 1964, the first postgraduate program, first ever postgraduate program, an MTech program in soil mechanics and foundation engineering at IIT Delhi was started. And the first batch was graduated in 1966, in which 4 MTech students and 4 PG diploma students from the soil mechanics and foundation engineering were graduated. And 1967, the soil engineering laboratories were set up at IIT Delhi, 1964, and then 1967, soil dynamics laboratory was also added actually. In fact, we all know in India, earthquake engineering awareness have started only after Bhuj earthquake significantly. But we can imagine way back in 1967 itself, the research related to soil dynamics started at IIT Delhi. The fourth convocation, the first doctoral degree PhD student from IIT Delhi was actually graduated in the year 1969. And we have a rock mechanics lab was added again in the year 1975, October. And the 1977, the postgraduate program in rock mechanics was started at IIT Delhi. This was one of the unique programs in the country, started in 1977. In 1978, Indian Geotechnical Conference in the name of GeoCon was organized at IIT Delhi, which was inaugurated by then Prime Minister Mr. Desai, Margaraj Desai. So you can see Desai and then Professor Shashi Gulati was here. And in fact, the true triaxial testing of rock, polyaxial testing of rock mechanics were all established. And the collaboration with the Imperial College London on research related to rock mechanics was also started in the year 1980 actually. And the labs were further strengthened, adding research related to marine geotechnology, foundation engineering in marine regions, all those started in the year 1980. The collaboration with institutional network scheme began in the year 1982 April, and the computational geomechanics related works was also way back, began in 1984 actually. And again, IGC was held in 1986 as well as 1998 at IIT Delhi. The 100th MTech student from the soil mechanics and foundation engineering graduated in the year 1989 after 25 years. That was at the Silver Jubilee Junction. An engineering geology lab was set up at 1992. And as Professor Bhandari was also highlighting, the 13th International Conference on Soil Mechanics and Foundation Engineering was organized in Delhi in association with Indian Geotechnical Society in the year 1994. So far, this is the only one international conference on behalf of ISSMG we have hosted. And as it is proposed, maybe IGS is also planning to bid for the one more international conference on soil mechanics and geotechnical engineering. The 50th PhD student graduated in the year 1997 actually. And in 1998, the 100th MTech student graduated in rock mechanics program. I think that is within 15 years self. And in 2003, the major curriculum revision happened. Our soil mechanics and foundation engineering program, which was originally started, was actually revised as geotechnical and geoenvironmental engineering. And we all know in the country, one of the thrust area has been environmental related issues and sustainability related issues have been highlighted in the last 10-15 years only. We are talking about way back in 2003 itself. The program have been emphasized with more focus on geoenvironmental related issues. That way, IIT Delhi has been always visionary in, formulating the curriculum and the research in advance ahead of the country's target. And in that similar line, we all know that this is one of the pioneering conference, 6th International Congress on Environmental Geotechnics as a part of the technical committee of ISSMG conference was held at 2010 in November at IIT Delhi. And we again hosted after 1998, 2012 Indian Geotechnical Conference at IIT Delhi in jointly with Indian Geotechnical Society. People still remember this 2012 conference whenever we go to the recent conferences at IIT Delhi. Again, the D Foundation India Conference, DFI India Conference was held at 2014. And the research lab, Geodynamic Laboratory, was set up in 2005 at IIT Delhi, which focuses on high strain characteristics of the rock. And, So we have large-scale model testing facility in foundation engineering lab was set up with the help of the FIST funding. And in 2018, International Symposium on Geotechnics for Transportation Infrastructure was also jointly organized with IGS actually. So IIT Delhi has been actively associated with the Indian Geotechnical Society and as well as in dissemination of the knowledge actually. The 100th PhD student graduated in 2018. When 2015 we celebrated the Golden Jubilee event, what is called Geotechnology 2030. That time we had 90 PhD scholars. In down the line now we have 144 research scholars graduated in the recent conferences. So we have an active research group now. And 2020 we had a unique event, 3-in-1 event, Geo-Environment 2020, in which we had an international conference and also a symposium wherein the geo-environmental experts and came deliver lectures. We have a hand-on field experience on demonstration of, geo-environmental sampling and characterization for contamination assessment and site remediation actually. That was one such unique event just before COVID. We were lucky enough to escape from the COVID and the event went very successful. And very recently, when I think the Silgaria tunnel issues were happening, that time we had an international symposium on tunneling, and in which more than 250 delegates participated, and world-renowned experts including Nick Barton came and delivered lectures. So with this milestone, we would like to say many more to be created at IIT Delhi, and thank you very much.
Next, I would like to welcome Professor Bapaditya Manna to discuss the history of the curriculum in rock engineering and underground structures.
So good morning, ladies and gentlemen. So I'll just talk about the brief history of curricula in rock engineering and underground structure. So as Professor Aitaraman already mentioned some history about that. Basically, you can see that rock mechanics laboratory started in 1975. Then MTech program on rock mechanics started in 1977, which is one of its kind of the entire country, open for both civil and the mining engineers. And in 1980, some research collaboration started with the Imperial College of London in rock mechanics. And then the Engineering Geology Laboratory was established in 1992. And in 2003, rock mechanics MTech program changed to the rock engineering and the underground structure. So that is the rename we have done, depending upon the need of that. And this is the first curriculum when first MTech program in rock mechanics established is 1977. So this was the kind of the curriculum we collected, and it was a structure of total 54 credits. And you can see the core courses, that is engineering properties of rock mechanics, and then structural geology, stability of rock slope and foundation, and underground structure. These are all the core courses. Then there was 2 laboratory component, rock mechanics 1 and 2, and that time there was a minor project in rock mechanics, and there are few elective courses were introduced that time. Geotechnical process in rock mechanics, then fluid exploration in rocks, advanced rock mechanics, case studies in rock engineering, and advanced method of analysis in geotechnical engineering and rock engineering. And finally, that time it was a major project in the rock mechanics. So that is 12 credits. So this is the kind of the structure when the rock mechanics in NDEC program was introduced. Then there was a slight change in the 1992 after the review of the course curriculum. So that has been, reduced to total credit of 60, and this was the kind of the structure of that. You can see that total there was a program elective of 45 credits, program core 45 credits, program elective of 9, and open category courses having the 6 credits. So total 60, and these are the courses you can see here. that listed down, and there are some red marks there which were newly introduced depending upon the need for the industry, and that was the recent advancements of the rock mechanics and underground structure. So you can see that there are new codes like finite element method in geotechnical engineering was introduced, and underground space technology, then environmental rock mechanics, and the independent study was introduced that time. So that was few modification done, and thereafter we have the one more curriculum review in 2013, and we have significantly reduced the total credit, considering introducing more upon the self-study component, and they will get more time to think about more be in contact with some kind of the industry. So that's what we are just introducing few important courses which are very much essential to get the job opportunity after they are graduated. So this is the course structure. You can see the program core was 36 credit. Program elective was 12, and there was no OC, and it was 48 credit course. So you can see that these are the two new courses introduced that time in 2013, emerging topics in rock engineering and underground structure, and numerical and computer method in geomechanics. These are the two other courses, and few courses were merged together, because there are so many courses were there, so we thought let's merge few courses, and that's what we are coming up with these courses, and this was the kind of the course structure which is still in continue. So this year we are again relook into it, because we have this year the review of this curriculum. Now these are some glimpse of our rock engineering laboratory which was established, and you can see that we have all kind of the facilities related to the elemental rock testing. We have the static triaxial test, cyclic triaxial test apparatus, high pressure triaxial test. We have the large direct shear test apparatus, and polyaxial testing equipment, and automatic compression testing equipment. So probably these are the best rock testing lab in India. So just little bit about the career and job opportunities who graduated under this program. So there are total the 7 verticals on which our students are working. Some people are in tunnel engineering, hydropower engineering, mining engineering, deep foundation engineering, ground improvement field, tailing dams, and the geotechnical investigation, material testing, and geophysical studies. And these are the few names of the companies where our graduated rock mechanics students, MTech students who are working mostly across all the companies. They are now in a good positions, and they are doing really well. And our rock mechanics engineering is participating all other activities in professional society like International Society of Rock Mechanics, Indian Society of Rock Mechanics and Tunneling Technology, Geotechnical Society of India, and Indian Geotechnical Society. And at the end, I must acknowledge and gratitude to our pioneer in rock mechanics, Professor T. Ramamurthy, who was the pioneer to establish the rock mechanics laboratory at IIT Delhi, and the same legacy was carried forward by Professor K.G. Sharma and Professor K.S. Rao. Thank you.
Now I would like to call Professor Devyan Bhattacharya to talk about the history of curricula in geotechnical and geoenvironmental engineering.
I think that's not required. I'll just. Well, good morning to all the dignitaries, Professor Bhandari, and all the respected members of our faculty fraternity, and my best wishes to the student community who are sitting. It's a really daunting task after what Professor Bhandari has set the tone. This is a glimpse of IIT Delhi, what it used to look like in the 1960s when it started at its humble origin. It started as an institute of technology, and His Royal Highness Duke of Edinburgh, during his visit, laid the foundation stone actually, because this was developed in collaboration with the British government at that point of time. And the soil mechanics and foundation engineering was started as one of the first PG programs in 1964. And presently this is running as the geotechnical and geoenvironmental engineering successfully quite over the few years. What it used to be, I think, has already been highlighted by my previous speakers, but I will only touch down upon the key aspects and the key points. The 1964 was the pioneering year, where it was first this program was conceived, developed. 1975, the soil engineering laboratories reorganized and took up the rock mechanics lab. You had introduction to geodynamics lab and introduction to soil dynamics as course in your coursework. And in 2003, this was renamed as geotechnical and geoenvironmental, whereas rock mechanics was introduced and renamed as rock engineering and underground structures. These were the kind of courses what was actually initiated in 1975-76, which was mostly focused on the fundamental principles of soil mechanics, as Professor Bhandari pointed out. And if you see, there were very, very limited amount of courses with limited amount of students being focused on particularly the fundamental aspects. Then if we see, move on to the 88-89 era, we had significant amount of subjects which were reintroduced and some additions, value additions we made. And if you see the green color actually appear where these new subjects were actually introduced, some of them being recent developments in geotechnical engineering, soil dynamics, machine foundations. Back in 88 when we are talking about, and this is at least 10 years before when Bhuj earthquake has taken place in 2001. Long before that, these subjects were already introduced there. We had then after in 2007-8, again a restructuring of the program where you had this offshore geotechnical engineering being introduced and being talked about, some of the new subjects and the new aspects of geoenvironmental engineering, geosynthetics, landfills and ash ponds as subjects which came up and talk about the urban problems, and that needs to be addressed as such in today's era also. And then in 2014-15, we had a restructuring of the courses a bit, and it remained a pretty much similar but with few value additions thereafter. This is the present state of the art, what we are running in 2023-24. Right now, what we are having as the kind of divisions of the subjects as some core courses and some project program electives, what we are running in the 2 different semesters. But we are looking forward to, from here, as the course curriculum review, because we are in a form of a course curriculum. What I would like to leave you with a food of thought is a relook at the problem what Professor Bhandari pointed out, that we need to go back to our fundamentals. Now fundamentals is what? That what do I call soil or Boden as it call it in German? Is it particle or is it continuum? Why? Because the fundamental definition what Professor Bhandari talked about, the principles of effective stress, actually was built upon the Coulomb's friction law, which was actually particle to particle friction contact. And if I see that all the definitions originate from the micromechanical origins of it, whether it is a friction angle or the direct tensy angle, they have their origins in the micromechanics, right? And we are using it or upscaling it to a very large problem, be it a retaining wall or a slope or whatever it may be. So it flows like a liquid. You can build a sand castle there. You have the desert storm, but all these are nothing but sand. And we call this what we are known as particle continuum duality paradox. It's just like light in optics, what we have studied. It's like the same thing, what it looks like a wave as well as the particle. What we see here is a beautiful animation. What I want to see, make you watch. What do you see? If I ask you, what do you see in this animation? Somebody would say, oh, it's a nice cartoon by a Pixar. So Pixar is a famous lab which actually makes these cartoon movies. And this is one of the movies which was nominated for Oscar in 2017. If I ask you what do you see here, you will say, I see a nice animation. But I would say, no, I see a sand heap which actually talks about the angle of repose. And that's exactly what my perspective of looking at this problem is. And this is how this state-of-the-art developments, looking forward to new things, are being implemented nowadays. So if you look at this, the sand is modeled as particulate materials in these kind of applications, because you need geotechnical engineers, you need scientific computation, you need people from that kind of background to do these kind of simulations, these kind of modeling. If I ask you what you see on your right-hand side or my left-hand side, what you will see across is that's a famous another animated movie called Frozen, where people from UCLA were actually asked to develop the snow modeling. And this snow modeling was done in something called MPM, which is the material point method, which is another cutting edge, fascinated tool, which is actually being used nowadays to develop landslide runout cases, what Professor Bhandari spoke about. At some point of time, we were building and we were restricted to limit equilibrium methods, where we only could say that these slopes could fail and they were subjected to failure. But we were not able to predict how much their land run out distance would actually happen. But we can now do it courtesy to this state-of-the-art techniques, where we can actually predict our landfill simulations. That is an Olaf, what you have recognized as one of the cartoon characters, where it's actually working on the sand and it is subjected to large deformation. So these are the tools which we look forward in our new course curriculum as such. Again, we come back here and I don't know if you can see this. These are some of the developments, which is the state of the art, where we look into the actual real interaction of the geosynthetic material with the particulate features what we are having. We can actually do landslide prediction modeling, where we can actually look into the impact forces, where it's actually used for mitigation studies, which were being restricted to quasi-static mode of failure in NDMA guidelines or the IRC codes, where we talk about these aspects. These are somewhat missing in our course curriculum structure we should be talking about. The last but not the least, what I would like to focus upon is the granular enigma, what I talk about. So, as most of you are already aware of, the Enigma was the German machine which the British actually broke to win the World War. So it's the granular enigma. Why I call it enigma, it's a mystery, still a mystery, and the granular mechanics is actually one of the most complicated mechanics compared to the theory of relativity. And now we are using this something called digital twins, or the avatar paradigms as I call it, which are nothing but a recreation of these particles, where you can actually make them work and make use of the computational powers what we are having, and we can use this to make our predictions more reliable with high fidelity and high reliability. So with this, I end my short glimpse of the course curricula and what we are looking forward to in the near future. May IIT Delhi grow more and flourish with your young ideas and bright minds. Thank you.
So now actually we are running short on time. So what we'll do is we will take the planned high tea break of 25 minutes, and we will resume at 11:10. So let's take a short break. Thank you. आ रहा है? Okay. So welcome back everyone. Now we'll continue with the presentations from Geotechnical Engineering at IIT Delhi. Our next set of presentation is on the imprints of the research that we have been doing at IIT Delhi from its beginning. So to talk about that, first I would like to call upon Professor Manoj Datta, who is going to speak about the research that he and his colleagues have been doing. Yes, yes, yes.
How does the pointer work?
Yes, yes.
Is there a pointer?
Yeah. This means forward, this is this. Down means forward.
Good. And that's where I speak. Yes. And forward is up or forward down? Okay. Good morning. Can you hear me? Wonderful. Professor Bhandari, my Guruji, amongst others, what a pleasure, sir, to hear to you. What a pleasure. I think you have awakened the animal instinct in all these people of what is soil mechanics. Right. I have 5 minutes to speak on behalf of 3 people, myself, Professor Ramana, and Professor Shahu. And I've been given this imprints, which I don't think that is footprint. Footprint is physical on the ground, imprint is in the mind. So I looked at imprint. What do I vividly recall if I look back at IIT Delhi? I've been here 40 plus years, and I'll just share those with you. So most vivid recollection that I have is of the 2 fathers of soil and rock mechanics at IIT Delhi, Professor Gulhati. Sorry, I'll just get used to this. Professor Gulhati, who's currently in the US, and Professor Ramamurthy, who's very much in Delhi. And they gave birth to soil mechanics and rock mechanics at IIT Delhi. And I show to you the universal triaxial equipment for soils, which Professor Ramamurthy developed in the 60s, and the triaxial setup for partially saturated soil set up by Professor Gulhati. They spent the 60s and the 70s in framing up the curricula, setting up the labs, and giving the starting point to all of us. So, in the 70s, one major change occurred in India. We discovered oil at Bombay High, and we made a lot of offshore structures. And that were exciting times for geotechnical engineers because we were venturing out to the seabed for the first time. The soils were very different from what we find on land, and it was there that my first very vivid memories come from. So offshore soil mechanics started as a major research area in IIT Delhi in the 70s and continued to be so till the 1990s. It was also called marine geotechnology. The group comprised of Professor Gulhati, Professor Vardarajan, Professor G.V. Rao, and myself. About 6 PhD students and 20 MTech students worked on it. And we had a great time working on engineering behavior of offshore soils, pile design for offshore structures. And these were 100-meter deep piles. Nobody had done this ever before. And anchors for floating offshore structures, stability of submarine pipelines, and seabed slope stability. So this is the Bombay High offshore platforms. They're all in 100-meter deep piles in 70 meters of water. So from this level, we are 170 meters down. And these are the kind of structures that we were dealing with at that time. We had intensive research collaborations with ONGC, Engineers India Limited, NIO, Norwegian Geotechnical Institute, McClellan Engineers. And what I recall was that when we first worked with offshore soils, we found sand grains which were hollow or which were cemented. This is all medium fine sand particles. And we gave some results in the Offshore Technology Conference which actually impacted pile design practice in such soils. So that was the most vivid impression that I had, that IIT Delhi touched a global practice of pile design in calcareous soils. shift in the 1990s, and the world was talking of subsurface contamination and ground pollution. And so the group here at IIT Delhi also went on to the bandwagon. And the problem in India was new dumps, old dumps of municipal and hazardous waste, the huge mountains that we see, and remediation or control measures for the sites. So from the late 90s till today, we have been working on environmental geotechnics and geoenvironmental engineering. And the group is pretty large. I don't know whether I have everybody's name here, but it's Professor Ramanna, Professor Shahu, Professor Yoti Raman, and myself from the geotechnical group, Professor Nima, and I think I have forgotten Professor Alapat's name from the environmental section, Professor Srikrishnan from the biotech group. It's an interdisciplinary group. And we've had 12 PhDs and 40 MTech students working on it, on landfill design, on stability of ash dikes and tailings dams for slurry ponds. Now we are into sustainability, reuse of waste materials, ash, C&D waste, slag, mining residues, tire chips, etc., characterization of contaminated sites and remedial measures. So it's a vast, vast field in which we are all working. So what is it that we are proud of? We are proud of the fact that we led the development and adoption of the curriculum for environmental geotechnics across the country. In the 1980s, there was no such subject. There was no such terminology. We made a model curriculum. We got it circulated through the AICTE to the various engineering colleges. The first set of guidelines and design manuals published by Central Pollution Control Board, the Ministry of Environment, and the Ministry of Urban Affairs all came through the hard work of our research group because we prepared the basic documents for them. We have till date worked on about 40 major sites in India. I mean, we've touched, there must be about 200, 250 major sites. We've touched many of them, and that's been a great experience. And we also organized a very prestigious conference in 2010, which had 250 international delegates descending to Delhi. And our collaborations here have been more with municipal corporations, NTPC, thermal power plants, and mining companies. So that's the other major vivid picture that is there in my mind. The third picture, which is based on the slide given by Professor Ramanna, is that from 1980s onwards, this phenomenal developments in numerical analysis, coupled with high-speed computing and useful softwares, that transition I've seen over the last 30, 40 years. And so it's all been the rise and rise of computational techniques at IIT Delhi. And I hope I can run this because, Professor Ramanna, your slides. So what it demonstrates is, you can simulate, for example, here, internal erosion taking place through numerical methods. And you can also simulate the failure as a consequence. Will it respond? I have clicked. One, yeah. So that's the failure on account of internal erosion, and then there is this liquefaction, poor water pressures developing, and the failure occurring on account of the liquefaction. And here you see how saltwater intrusion is taking place from the sea into good groundwater, and here how the landslides run out, which is happening by numerical simulations. So with this, from the 1960s till today, it's been an exciting journey. If I was to live my life all over again, I would do this. Couldn't be better. You guys also have a great, compelling future in front of you if you stay on in this field and don't run away to engineering services or administrative services. But those of you who will make the correct choice after listening to Professor Bhandari's lecture and stay in this field will have a very great future. Thank you. All the best.
Thank you, Professor Datta. Now I would like to call upon Professor Bapaditya Manna to discuss the imprints on behalf of himself, Professor Tanushree Chakravarti, and Professor Ayuthi Raman.
इसमें पॉइंटर कौन से आप लाइट इसमें
पॉइंटर है
हाँ ठीक है
ये फॉरवर्ड
और नीचे वाला ओके ladies and gentlemen, good morning once again. So I'll be presenting some significant research conducted by some group of faculty members in geotechnical engineering, IIT Delhi. So here you can see that when myself and Professor Aitaraman joined in 2008 to 2010, actually we tried to introduce some kind of the model testing and model testing of the various geotechnical structure. And Professor Aitaraman developed a very beautiful, the model testing facilities where he started with working on the rock socketed pile under static and the cyclic load. And here you can see the arrangement of the making the casting of the blocks and protection sleeve for the model piles, and you can see the model piles based on some scaling law used, and accordingly the stiffness has been modified. And here you can see the testing facility under the loading frame, and he has created the kind of the rock foundation there. And these are the various type of the arrangement he has made for the purely vertical load and inclined load, and for the smooth surface, rough surface. And here you can see the percentage change of this. And what the significant outcome is there, that measured effective length is about 1 to 3.5 times of the pile diameter, and estimated effective length is about 2.64 to 3.2 times of pile dia. So you can refer these papers where all the research carried out by the Professor Aitaraman and his research team is already there. And then he also started with a new domain, that is the model testing of the tunnel raft or the pile interaction in the urban areas under static and the seismic loads. And here you can see this kind of the model testing arrangement he has made with the instrumented tunnel. And basically you can see that he has the given in terms of the non-dimensional form, that the distance from the tunnel to the what is the variation of the total displacement, how it varies with the distance of the tunnel and the pile or the raft. And also you can see the construction stages, that means at the various stages of that, how the strain varies on the top of the tunnels. And he significantly carried out some numerical models, and this kind of the response has been shown, that how when the depth of the tunnel vary, what is the response in terms of the displacement and the strain. And here this has been published in various journals. And what the major conclusion made, the critical distance between the pile and the raft and the tunnel is about 2.5 times of the tunnel diameter to ensure the tunnel safety. And he has formulated a complete guideline that what should be the optimum spacing and how you can introduce the tunnel in the liquefiable soil, what is the additional thrust and the bending moment to have incorporated in the tunnel line design. So this has been the significant contribution made by the Professor Aitaraman and his research team. Next, these are the few of my, the research I recently carried out, that we had one project from the RDSO, and we are trying to solve a problem of the development of suitable design for the bridge transition system for different axle load and different velocity for the Indian Railway. So that when the train moves from the embankment to the bridges or bridges to the embankment, there is a sudden change in the stiffness. So therefore, there is a significant settlement happen at the interface or the kind of at the transition zone, and people feel the discomfort. We all experience that when train is moving from bridge to the embankment, we suddenly feel a jerk. So basically, Indian Railway tried to address this problem and how to retrofit the existing bridges and what kind of the design methodology we can adopt for the new bridge embankment transition zone. That's why they gave some project on that, and we did a significant research on this, and we did the numerical modeling, and also we tried to do kind of the real-time simulation for that. And you can see that what is the variation of that, we just try to predict, and finally we have shown that this kind of the S-curve we can get, to make a very smooth transition. So where you can see that this is the bridge side, this is the embankment side, and how much variation of the track stiffness for the various axle load and the various velocity of the trail. So that has been introduced in inclusion with the geocell,
So we try to introduce the geocell to strengthen that, the transition zone. And based upon the design guideline that Indian Railway use this design, and they are implemented more than, more than 1,000, existing railway bridges where they are adopting this and doing the retrofitting. And we are having some, kind of the instrumentation has been going on to see that how our numerical prediction is close to the actual, performance of the track. Next, come to this project. I'm talking about the metro-induced ground vibration. So this is a field measurement, and we did this measurement in terms of the elevated structure as well as underground metro in the Calcutta region. So we choose the various area which are very prone to the vibration, and it affecting the nearby structure. And also for the underground vibration, we choose the many location. And we did the measurement there in terms of with the help of the geocell, with the help of the geophone and the accelerometer and the dynamic strain gauges we attach. So we just try to see that how the vibration propagate from the slab level, track, slab level, then pier to the pile cap and to the ground. So we have the entire measurement of this chain, and we try to see that how whether it's really vulnerable. And what the limit of that vibration we try to see. So here you can see the typical result that when train is moving in this area, we can see the time acceleration response, and then we make the Fourier transform to get the FFT, and then we can see in terms of the human perception, then we convert to the the VDB. So where you can see that there are, as per the FDA guideline, there are certain ranges here which is not acceptable for the human, which is very sensitive to the residential people, and which is very limit for the sensitive equipment. So we can see that what is the range of the vibration, and we kind of microzonation we have made that we identify some area of the Calcutta region which is very sensitive, and we have given the threshold distance from that the axis of the track, that this much of distance is required. You have to be very take care of that. So we try to did some zone and similar kind of the research we are also planning for DMRC. We recently have one MOU that they are giving us some site location in the Delhi region, and we are trying to do the similar study in the Delhi region. So this has been under one CRG project from the DST. So we carried out this research, and this is the another research from the DST Supra project, that we try to see that how we can reduce the passenger discomfort due to the vibration, and how to increase the track maintenance, and how we can develop one kind of the pad that can be placed below the slipper and the track. Okay, so this is the conventional pad where metro people are used, and we develop one kind of the meta pad. Is basically the auxetic structure we have made it. We made some kind of the mass in between, and in between there is some kind of the pad we have introduced, and we have did the model study significantly for the as per the specification of the high-speed railway Mumbai Ahmedabad. We follow the same scale down specification of that, like CBL, HCL, and the soil, and we did the testing for the high-speed velocity or high-speed rail configuration, and we did the measurement there. And this is the typical result for the conventional pad and the meta pad. And this is some analytical formulation and there. So the outcome of that is that with this meta pad, we can reduce the vibration in rail about 30% for speed about 150 km to the 300 km per hour in comparison to the conventional rail pad. And this concept has been filed as a patent. And that the RDSC is going to give us some test track where we can put this kind of the railway pad to see that how efficiently it can work for the actual rail, because everything of what we have done based upon the model testing. So we need to see that how sustainable these pads are for the real condition. So these are some research carried out by Professor Tanushi Chakraborty and her research team. This is about the material characterization under static and dynamic loading. She has developed that lab where she installed that SHPV test for the rock and the soil. This is a very high strength dynamic testing of the rock, and she also introduced the shock tube test on the concrete and the soil. So you can see the various samples he has tested, and we can see the different type of the crack has been formed due to the high impact of that. And these are the pressure sensor, and you can see how when the impact has happened for a very short period of time, how is the time the pressure dissipated. So this kind of the response he has obtained, and also did a significant research about the blast analysis and the blast resistance design of the above and the underground structure. So particularly for the subway tunnels, railway, underpass, blast door, and sacrificial wall, water tank, and the ammunition storage. So she has done a significant numerical modeling, and you can see that how the stress is accumulated with the time, and she has made a complete guideline of this. So that is a wonderful contribution by the team. And last, this is for the renewable energy. So she did, kind of the testing, real-time testing for the geothermal pile. She installed some pile in the IIT campus of about 15 meter, 14 meter, and 10 meter length of that. And you can see this arrangement, which is connected with some sensors, data cable, and with the data logger. And you can see the different type of the section used, like U-shape, W-shaped, double U-shape, and the spiral shaped. So these are the kind of the measurement, and this is the measurement room where this instrumented has been stored, or data are recorded there. And she also did a significant numerical modeling, and finally she come up with a design of the geothermal foundation. So this is the first ever in India that IIT Delhi taking a lead upon the design of the geothermal pile. So I would like to thank everyone for giving this opportunity to present this one. Thank you.
So next I would like to call upon Professor Wangla, who is going to present the imprints on behalf of himself, Professor Shirole, Professor Debyan Bhattacharya, and Professor S.K. Sinha. Please welcome Professor Wangla.
Thank you. Thanks for this opportunity. And this is definitely a task for me, because so far you have seen what has been done, what has been developed. And this is a new generation faculty who joined just in 5 years from now. And we belongs to the ChatGPT and big data. And of course, we are not looking for the best fit curve, for sure. We would like to focus on something very fundamental as well as a state of art which takes advantage of the technology. This perfectly aligns with what Professor Bhandari had made it clear, what is a futuristic study that has to be done. So before, what I'm going to present is summary of 4 of us, and I'll let you know where individual faculties group are contributing. Okay. So yes, these are 4 verticals that we have put for ourselves, which definitely is the need of the hour, and that basically also aligns with the national priorities as well as fundamental research. As you see, so I'll just walk through. So what I did is I have put all these research that 4 of us are doing in 3 thematic areas, where you see the first one, bio-inspiration and biomediation, and then geohazards, and then innovations and sustainable alternatives. And when you look at these bio-inspiration, biomediation, I would like to just introduce that we are looking at the nature. Of course, it has been done from the long. For instance, geosynthetics, it has come from the root-inspired. Similarly, what we are looking at here is that to address a problem that conventionally we face, that is site characterization, we have limitations in that. So we basically looking at some innovative ways, looking at the animals. For earthworm, you see which goes peristatic motions, which has expansion, contraction, move forward, which can go in any direction. So one of our colleagues, like Deban and his team, is extensively working on numerical simulations. And of course, my team and my students are working on experimental validation for this same study. And these are some simulations that shows some of the cone penetration and pressure meter modules and tip advancement that we have simulated in the lab. So this. Yes, where is the, right, yeah. So this, yeah, got it. So this and this. And you can see there's some beautiful simulations that's already in place. And of course, we're working. This is an ambitious project. I would say it's not just one-night job. And then one other thing that we're looking at the snakes. What you're looking at the snakes, this snakes has very interesting properties of frictional anisotropy. It moves in one direction without much resistance, in other direction it has some resistance. So we are taking advantage of these concepts, and we are developing some interesting models that includes split-set rock bolts, which suffers from the frictional resistance because it has no surfaces. And what we are looking at is when we install, we should use less energy, but when it is in the performance mode, it should have higher capacity. So these kind of some innovative thoughts we have, and we're working on that. And we are still working on. And the other interesting thing that is geohazards, where we are extensively focusing what, as Professor Bhandari said, go visit the site, learn, turn the disaster into knowledge. So that is one first step that we are focusing, where anywhere the disaster happens, because this provides a volume of data which is very important for you to turn the disaster into knowledge, and which helps you to visualize and understand what went wrong, and then improve your fundamentals as well as applications. So, and the next project that in the geohazards, my colleagues Dipanshu and Debayan, they're working on experimental and numerical simulations on how these mitigation measures can help us in preventing the disasters or devastations that takes place in the landslides. So these kind of impact loads have very devastation effects on structure as well as human. And next simulation that basically you see, this is a nice simulation set from the Deban's lab, which clearly shows that how the barrier structures can mitigate reduce the impact of these landslides on the neighboring structures. And the other one that in the geohazards, we have mitigation. We have seen modeling, mitigation, now we are looking at the monitoring. So Sinha and myself, we are looking at the monitoring techniques that includes optical fiber, as he currently presented here, where we are working on optical fiber, which would help us in monitoring the geotechnical engineering systems. And the one more project that I'm working with my student is acoustic-based early warning system for predicting. As Professor Bhandari said, the prediction is something which is important. Yes, we are putting significant effort in IIT Delhi to develop some systems which can predict and help us in avoiding the landslides or mitigate. And then, coming to other innovations and sustainable alternatives, we are extensively working on developing 3D printers. Why 3D printers? 3D printers helps us in getting the structures which are really important for us to do laboratory investigations or the field investigations, because this helps you to print some complex patterns which is not possible with the real materials. So this is something we are doing at our lab, and these are some structures. And this would not be possible without the funding that we have received. Almost we received 4 crores from different funding agencies so far, and we are progressing. I hope we'll be, maybe next 5 years, we'll be having some beautiful outcomes from this for sure. And other main objective that we as a young faculty have is entrepreneurship, startups. So whatever the research that we do, our students should also get, it's not just only the faculty position after PhD, it's also like having startups. It's employer and employers, not just employee. That is something we have always focused on. And with that, thank you. This is all from my side.
So with that, our presentations about geotechnical engineering at IIT Delhi ends here. I know Professor Bhandari has to leave for another meeting. So I would ask all the distinguished speakers to kindly come on the stage, and let's have a group photo with him before he leaves. So please, can all the distinguished speakers come on the stage? Yes, of course, geotechnical faculty as well. Yes. हाँ 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 हाँ.
So we have two photos, one with all the speakers and the faculty, and then we have a photo with the students as well, okay, as a group photo. Okay. If there is an issue, we send it to our lab. We need an assistance. And we'll Photoshop. Sorry, with the students also will take. I'm extremely sorry. Also to come. Come on.
Here.
मेरा प्रोग्राम तो बंद कर दो, क्या है 10 मिनट का कोई नहीं है, डोंट वरी.
हाँ?
Anybody wants to come here and so leave it.
Very careful how many pictures you have here.
Maybe you want to finish it up in 2-3 minutes. Let's finish.
नहीं नहीं नहीं.
I will take over. Let's not waste time. Hello?
हाँ?
It's done, man. Because बाकी लोग भाग जाएंगे.
कौन भागेगा? अरे नहीं सर.
Already quarter to 12. You don't want to waste time.
ठीक है सर, क्या करें? Everybody is speaking so much. I have one question I want to ask.
Sure.
Okay. So we all have just seen like how over the period of the time the geotechnical engineering has become interdisciplinary. So before we go to the next presentation, I just have a small trivia question. So we all know about the Leaning Tower of Pisa, but do you know the Leaning Tower of Surhusen that is located in Germany? It is in fact the world's most leaning tower that is unintentionally tilted, beating the world's most leaning tower of Pisa by 1.22 degrees. Can you guess what is the cause of this much lean? Of course, it has to do something with geotech, and it must have happened over the period of time. So there is a time effect, likely. Any guess? and this structure is in the 19th century. Think of Taj Mahal, that would be hint. Anybody has any? Huh? Not necessarily. So it had the same foundation as Taj Mahal. So something happened with the foundation. Huh? Sorry? Rotting of piles? How? Like over a period of time?
So it may happen like there is an issue with the piles, and because of that, differential settlement happened.
Excellent. So that was the reason. Because of dewatering, the piles were made up of oak tree, and because it was submerged in water, it was all safe. But over the period of time, because of dewatering, those oak piles got exposed and they got rotten over a period of time. That led to this much tilt. So I would ask my volunteers to please give a gift to Venkatesh, the first question he answered. And then, what is your name? Ashok. So please, we have a gift for you. MTech first year. Excellent. See you. Okay, so moving forward, we have a presentation from Professor Ramanna, who is going to talk about dreams coming true. So let's please welcome Professor Ramanna.
I'll just keep it very brief. I know we are overshooting, so. You already started dreaming. So we'll make it very small.
This is forward, this is laser. Let's speak from here. Don't move.
Good morning, everyone. So I don't want to take a much longer time, and my friend told me don't make jokes, you are online, am I right? So I'll keep it very brief. This is like in 2015 we had Geotechnology 2030, and you can see our faculty colleagues there, former faculty colleagues, and you can clearly see that in the last 5 years 4 young faculty members came in. Okay, so of these, I think Professor Varadarajan is no more. Rest of our faculty colleagues are currently here. And a close-up shot. Now, in 2015, we had these research areas which we wanted to focus on. I just want you to glance through them. Keeping ahead with the future, people wanted to work on bullet trains, energy geotechnology, geological materials under high loading rates and the blast loading, physical, mechanical and thermal behavior of the rocks. And it's a time to look back and see how much of that we have achieved. Okay. Most of you got the invitation from Professor Sumit Kumar Sinha, am I right? He is our youngest colleague who has been here for a very short time, and we thought as a section we figured out everything, but he gave us a jolt. He came in and had his own startup, Brahma Sense. I mean, we were very complacent and comfortable, but this is another way of looking at the things for us. He also works in pile foundations in liquefiable ground, which we also had it as a dream at the time, and geothermal energy. We have another younger colleague for whom I think a sand grain is the whole world. He can see the entire world in the sand grain. Whereas, if I think of a sand grain, I'll think of the beach and a cold beer if it is very summer day. But look at him. For him, it is endless possibilities. And we have another colleague who joined us in rock, and he really takes the research to a next level. He cracks into the rock to know about it. See what kind of instruments he's using. He uses everything, whatever we learn in the textbooks, to look into the rock. And he even is trying to modify the voids with the crystal growth. This is another person who will change the way we see the things. He uses high-end 2D, 3D morphological characteristics, and if you give him a picture over a WhatsApp, he will analyze it for you. And he also is fascinated by the animals. He works with all the fascinating animals, and he says even you can learn something from the snake or from bacteria. He is using this to stabilize the soil. Then we have another faculty. I'm sure you will be shocked by the amount of funding that was secure. And these slides were already given, and it is for national security and everything, geotechnical engineering for that. Renewable energy and the sustainability. And this is from another colleague who says, I am done with laboratory model testing. With element testing. We want to do model testing. And that was also one of our dreams long back, and it is coming true, and he explained. Then there is another professor who says, I am done with element testing also. I want to go to the field. And he installed the stone columns in the field using his own money, and then he's trying to come up with some theories for it. And another thing we are working here is on novel framework for investigation at contaminated sites. This is also the dream that we want to get a sample that is truly representative without any cross-contamination. And some research scholars are trying to push the instruments and then try to extract the groundwater from different depths. And this is, you can see a soil sample. This is a black colored sample. This is from a landfill from a certain depth. He got it. And this is possible because of the machine which you saw in the previous slide, which is the direct push system, which is the first one in India. And I will conclude so that I won't take up your time. Keep dreaming, and thank you.
Thank you, Professor Ramanna. Now we'll be shifting gears to have some presentations from practitioners, followed by a panel discussion. So please join me in welcoming Sri Ravi Sundaram, who is our alumni and also a reputed geotechnical consultant with an experience in India and abroad. He is currently one of the managing directors of Sengers. So please join me in having Sri Ravi Sundaram.
Thank you very much, Dr. Sumit. I'm greatly honored that you have invited me to talk at this occasion here. This topic which I'm going to talk on is skill, experience, and judgment in geotechnical engineering. I will be talking with special reference to geotechnical investigations because that's what I have been doing all these years since I passed out from IIT. So as you know, geotechnical engineering is everywhere, and it is the support discipline for all civil engineering disciplines. Whether you're talking about structural engineering, earthquake engineering, waste treatment, transportation, urban infrastructure, it could be heavy industry, water management, hill area development, everything requires geotechnical engineering. And you will see it in every facet of life. But today we are talking about building big. And when you want to build big, then geotechnical engineering becomes very important. So there is talk about smart cities. Infrastructure has gone to a new level, particularly industrial plants, power plants, refineries, tall buildings. We are now don't bat an eyelid of 50 to 70, 80 stories buildings, metro and railways and road bridges. Even culture, you have these huge tall statues coming up, all kinds of buildings, temples. We had the Ayodhya Ram Mandir. So much activities are going on. And the future, I would say it is without any limits. So geotechnical engineering is the basic service for all kind of activities. So what does the modern age geotechnical engineer, what kind of skills does he have to possess? Obviously has to be multidisciplinary skills. Considering geotechnical engineering as a subset of just civil engineering is no longer sufficient, because narrow perspectives could stifle progress, it can stifle innovation. So you have to widen your perspective, your understanding, interact with professionals of different disciplines, and link geotechnical engineering with other geosciences like geology, mining, environmental and earthquake engineering. That becomes very essential, and not just other geosciences, other engineering disciplines. Electrical, mechanical, chemical engineering, you have to understand these to understand the tolerances of various machines, environmental impact. In fact, when we were working on the Ram temple, we had to understand some of the religious requirements of the temple to be able to do the geotechnical engineering right. For example, they said that you cannot use steel in the structure. But modern civil engineering is about reinforced concrete. And if you can't use steel, then the whole thinking has to change. So you have to acquire that kind of a knowledge and skills for globalization. So that is the new paradigm for all engineers today. The challenge, of course, is how to navigate between these different bodies of knowledge. What are the skills that you need to acquire? So we have to go beyond the classical geotechnical engineering, the classical simplistic concepts, and take on new challenges. Environmental engineering, ground improvement, engineered barriers, rock mass behavior, sustainability, energy production. We are doing so much work on renewable energy and projects like solar energy and wind energy. The geotechnical requirements are very much different from what we are used to. And of course, when you talk about theoretical versus practical research, that has been the topic of discussion here. Computers, of course, they have revolutionized theory, but and solutions which were not easily possible, you can get it with the click of the mouse. But as Professor R.K. Bhandari said, observational method, use of engineering judgment should not take a back seat. It is very important. Field monitoring and instrumentation, that's what will provide your understanding of soil behavior. So input the field observations into the theoretical model, and then you develop your solution by back calculating the design parameters and revise the design based on the observations. So then you can validate your design based on real-time data. So research and development should address non-quantifiable factors, something you cannot put a number to. And of course, the field experience of the engineer becomes most important. So your engineering solution has to be reliable, economical, and practical, but most important, it has to be amenable to speedy construction so that the performance of the structure is as designed. So now we talk about experience. What does the experienced geotechnical engineer, he would consider field studies, success stories, and failures. Failures are more important than success stories in trying to figure out how to solve a particular problem. So you have to be flexible yet systematic, have the proper choice of investigation techniques, and then select your suitable analysis methodology. Most important, sound engineering judgment. So when we are talking about having the right kind of geotechnical data, I am very much, I like this geotechnical input pyramid from bronze, silver, gold, and platinum. As you move up this pyramid, your factor of ignorance reduces. I don't look that much on factor of safety, should be more, but the factor of ignorance has to reduce. Your reliability of the design has to be enhanced so that you can reduce the cost of the foundation and the construction time, but yet minimize the possibility of failure. So if you will look at a geotechnical investigation, move from a bronze level to a platinum level, so the investigation would be a very limited investigation here, but as you go towards the platinum, gold and platinum levels, you have a lot of borehole in situ tests, advanced laboratory testing, and all that. And here, the geotechnical engineer in a gold or platinum level would be an experienced expert. Design parameters at a bronze level is guessed, whereas you have site-specific design parameters. So the analysis is also, almost none at the bronze level, is just throw some numbers. To advanced numerical modeling, maybe design rules are also thumb rules. You have optimized serviceability criteria. The foundations, of course, if you have a gold level or platinum level, you have optimized, practical, easy to build, saves not just money, also saves you time. Risk level goes down here, but the cost, of course, of the investigation would be much higher if you were doing gold or platinum level investigation. But always you spend a little bit more money, and what you save on the foundation cost and time is much more. So what I would advise is that you move towards gold and platinum levels of investigation. Now, if you are doing SPT, let's measure the energy transfer for a greater reliability. Move on to CPT, CPTU, dialitometer, pressure meter, vane shear tests for better assessment of the soil characteristics. Use of geophysical testing, advanced sampling and laboratory testing methods, remote data acquisition. So all that is coming now. So in situ testing, that's the most important thing, that if you have field instrumentation, you have in situ tests, you can have a better understanding of the behavior and effective adoption of advanced technologies. You will be able to get better solutions. So what kind of new available techniques are there? You have very good drilling rigs available. SPT energy measurement standardizes to 60% energy transfer, so you are able to correct the uncertainty in the SPT measurement. There is the CPTU, seismic CPT, pressure meter, Footing load test, much better than plate load test. Geophysical tests, there are a whole lot of tests which are available nowadays, which can be very useful for your design. So here are some drilling rigs. These kind of drilling rigs can, increase your productivity on sites much faster, get you better quality samples. SPT energy measurement. So you have an instrumented rod here, which is inserted here. This is a auto trip hammer. So you measure your energy transfer. So this is, as I told you, a 0.6 meter rod with instrumentation on 2 accelerometers are bolted, and also you have sensors to measure the stresses, so strain gauges. So you can then measure this SPT energy transfer. CPTU is now very common. Here, this is a crawler-mounted CPT rig. This uses anchors. The CPTU, you have a pore pressure measuring sensor also at this thing. So these are the kind of cones which are being used. Typical CPTU results. So you can get a very good idea of the soil type also. The pore water pressure is being measured here. Seismic CPT, here you have 2 sensors which are measuring so this is the top sensor and the bottom sensor. So the electronics there, you are able to measure the shear wave velocities. This is the seismic CPT in progress at one of our sites. So I won't go into all the details of the advantages, but you can see speed, continuous profiling, increased productivity, a lot of saving in time as well as cost. Of course, the additional sensors like to measure shear wave velocity, electrical resistivity, thermal resistivity, all that is possible. You get a large volume of data. Soils that are difficult to sample, you can get good data from there. So instead of trying to collect undisturbed samples of loose sand or soft clays, CPT can give you the data. Minimal surface disturbance because you are not having any drill cuttings generated. Higher bearing capacities and pile capacities can be justified by the CPT. Of course, every test has its limitations, one of them being that no sample is obtained. It's a little complex because you need the field technician who goes to the site needs to understand how to operate a computer. Availability in India is still limited. Of course, rock and strata containing boulders, you cannot use CPT. Come to the pressure meter, the dilatometer, all this is being done today. The Menard pressure meter, you see the photograph here. So this is done in pre-bored holes. So you get all these parameters from the CPT. This is the pressure meter test in progress. Engineering analysis, of course, advanced analysis, reliability and risk assessment, value engineering, using a probabilistic approach. Centrifuge modeling is also being done nowadays. Of course, numerical analysis is very popular. Let's try to move towards advanced analysis too. But most important thing in engineering analysis tools is your engineering judgment. The pet cliche being used by many people, geotechnical engineering is a science, but it's practice and art. So what is that art here? So you have data. You must have good quality data to be able to take your decisions. You have referred to standards, technical specifications to be able to interpret the data. You should have that kind of right experience to use all this for an engineering judgment so that you can take the right decisions. So most important, of course, is to remove the disconnect between research and practice. That has been the discussion. So if this is the kind of samples that are being collected on the site, then all kinds of advanced finite element analysis is useless. So I'll talk a little bit more about engineering judgment. So the judgment has to be based on knowledge and experience of that engineer to be able to provide a reasonable solution. So years of experience and resources are available. You may be able to make a judicious situation, but of course one shoe does not fit all. So you have to be able to understand this concept of how the way it has to flow. You analyze the data, you make the predictions, and you should be able to take the right decisions so that you have a successful project. You should be ready to go beyond the codal provisions and out of the textbook situations to be able to work out the right kind of a solution. So to be able to realize this on the ground, the design, the geotechnical engineer has to be involved throughout the project, including the construction monitoring, site visits, etc., regular design meetings, site meetings, design iterations, all QA, QC reports, foundation load tests, pile integrity tests, etc., must be reviewed by the geotechnical engineer. Just don't throw that pile of reports in the dustbin, use it. So mandatory instrumentation with proper data logging for important structures. This is now being talked about in the country, but not yet very effectively implemented. But what I'd like to show you, if this is the quality of piles, no matter how conservative your design is, the pile is never going to behave as you design it. So let's talk about the future. I first go to the investigations of the future has to be technology oriented, increased use of computers and softwares, remote data acquisition, superior quality of sampling and laboratory testing technologies that are more reliable, CPT, pressure meter, dilatometer. Hopefully SPT will die its natural death, but as long as SPT is alive, please measure the energy transfer. Geophysical and remote sensing is important, and also a national database of geotechnical data. If we can have that, Hong Kong already has it, but Hong Kong is a very small country. If we can have something like that, then we should be able to get a little bit more understanding of the geotechnical properties of the soils and rock in India. When we talk about geotechnical constructions of the future, we're talking of modern piling rigs and big rigs for ground improvement. Of course, use of electronics, technology, and software to guide construction of piles. Warning signals if something is not going right. Technologies using more efficient rigs, and superior testing methods and quality assurance. So that's what we should see in the future, hopefully. With that, I close this presentation. Thank you very much. Hope I was able to keep the time. Thank you.
So in the interest of the time, we'll move to our next speaker. Acha, haan. Sir. So now I would like to call Professor J.T. Sahu. Is he here? Oh, he's not here. So I would like to call Professor Datta. Please. Maybe. So it's a small token of appreciation from us.
Image is more important than the reality. We'll do the whole thing.
All right. Oops. Huh? Oh, no, no, no. Maybe I. One second, I was just. Okay, just quickly, maybe a quick trivia question, because we just heard about what is the importance of practice and how failures can help us in gaining more knowledge. We all know about the Proctor test. Ralph Proctor actually devised the Proctor test. It was World War II, where there was some events that happened which led to a modified Proctor. So can anybody identify what were those events that led to modified Proctor test? Huh? No. Maybe kind of. Yes.
The runways modification, I think.
The runways had to be?
For the World War, during the World War, they have to come on a runway, but the runways are not capable enough to take the load. Therefore, they need high strength ground. Therefore, they come with this modified Proctor test, I hope.
Excellent. So that was the reason. As you see here, the initial Proctor test was not enough, did not enough provided the strength. So that's what led to the modified Proctor test. Yes. So no, not that gift. So we have a gift. Please hand it over to Upendra. So now moving forward, we have our next speaker, Dr. Nishit Gupta, who is the Chief Technology Officer of Sistra India, having extensive experience in underground metro projects. He will be discussing on the multidisciplinary approach of the design of underground structures. So please welcome Dr. Nishit Gupta. This is forward, this is laser.
So now it's afternoon, so very good afternoon to all, and thanks for inviting us for this particular lecture. This is, I can see a lot of young people here, so my presentation is more towards is how, even I have a PhD in something, but what I'm doing is basically for so many disciplines and so much. So finally, I will just highlight this. Terzaghi is, Austrian mechanical engineer, geotechnical engineer, and geologist known as. So what this tells us, all the engineers should have a quest to understand the things from first principles. As long as you are there, you are able to question your conventional wisdoms, challenge those things, just ask questions, And most of the people have watched Three Idiots, have some lessons learned from that. And that's a very good thing, and that's what I tell all my young people to do, start asking questions. Don't get convinced something. I don't know who said it, but I think it was Einstein, who told once, look, if you can't explain your physics to a 10th class boy, then there is some problem with your understanding. So as a senior people in this industry and all those things, we should also have a quest to make it simple so people can understand And then only it creates passions to do something really good, which is good. So this is what, I will just start with this, I'm sure. Okay, so my presentation is more about designing of underground metro work, because I don't want to expend it too much. I have a little time here. And I work for Sistra, which is basically a consulting engineering company having more than 1,200 design engineers. All sorts of disciplines. We work under one house and do a lot of things. So we came across a lot of things. And as of now, in the current age, as professors, also young professors, everything is multidisciplinary. And I'm not sure why we are not doing it. I think any PhD should have 5 papers for the other disciplines. Whether it is also, I'm just running through it. So this is, I'm skipping this. So look at the first thing which we came across, and when we start doing things, when I started my career, I was amazed, We know very little about what is driving what. So let's look at the stakeholders. The government, the metro rail corporations, funding agencies, contractor consultants, technology providers, regulatory authorities. All these things, somehow I felt that real engineering gets lost in the bureaucratic process. They don't understand what we say. And we are always technical peoples are odd man out. So what we started doing it, we tried simplifying the things. Whoever understands whatever language, we should have an ability to communicate in that language. So, and things work. Say if I'm working for a contractor, he got this job for a very small, we call it lowest cost bidder, L1. So obviously everything is driven by business and foreign. So we as an engineer have to tell him, look, I can do something different for you. This will save you so much. And then he gets traction and all those things. So we have a lot of things. I will just moving a little bit fast. So this is a typical underground station. You can see it's nearly a factory inside. It's a diaphragm wall, geomechanics, structural, surrounding buildings, congested infrastructure. Nothing goes when you excavate something, you hit some utilities there. And so many things inside. Power, safety, you have to take the passengers. If there is a fire, how will they get out? Everything has a standby system. We have controls, this, that. All together, it's a big view of this. You can see ESS, TSS, fire cylinders, sump pits, fire escapes, public area, free escapes, supply exhaust, AHU rooms, TVS fan rooms. All these has its own specifications, own constraints. And once you start making big, it becomes another problem. We have land issues, we have utility issues, and we have cost overruns. Land is the most scarce things, and we get challenged all the time for it. So these are some of those things. I'm just skipping it up. It's a sort of a factory inside with so many disciplines, so many all those things. Further down the slide, I will show you. So these are some of the underground stations we are doing. You can see the building is at the top. Building is at the top, and then we have to really do a deep cut because nothing we can do here. This is the underground station in Bangalore. Earth retaining systems, you see have a box next to it. This is a traffic decking. There is a diaphragm wall. This is Chennai Phase 1 extension. This is sort of things. So what I'm trying to say is there is nothing like a conventional textbooks happens. Everything in our profession has to be customized to the site requirements. And that's where the challenge is, and that's where we feel that we are doing something. Similarly, I can show you a lot of these things. You might have seen all these things, ground anchors, Mumbai Line 3, and stuff like that. Now, this is one of the, in Hutatma Chowk station in Mumbai Line 3. You can see so many, all those are heritage buildings. And some of the caverns are below these buildings. This is Vidhan Bhavan. Sorry. This is Vidhan Bhavan station. You can see this blue cover here. This is an internal internet C cable taking a lot of data and feeding the Bombay, and we are building next to it. So all these challenges, this is a temporary decking. So when you go with it's so simplistic to run a Plaxis or a wall up or do a flat 3D and whatnot. But nothing in the ground is homogeneous, isotopic as we feel. We rely on measurements. We rely on monitoring data because there is a lot of risk involved in that. I don't know why this, okay. So these are some of those things. IOCL pipeline leaking. When we expose it, the pipeline started leaking. We are going to do next excavation to it. So these are the challenges which needs utmost care in doing all this. Utility supports, hangars, limitations, vehicle movement, noise. So these are other, again, this is Mumbai Line 3 and some of the ground anchors. I think Keller was also involved in that. And I just show you this one. Anyway, this is not working. No, it's okay. Okay, doesn't matter. Anyway, this is a lot of water is coming through that, and this particular thing we thought that there is nothing, but it was connected to the sea, and the entire station was full with water. So there are many such things. Yeah. Yeah, we have to really do the grouting to seal it where it is coming before we go and do this. So, okay, so it started working. So let's move on. So now we have a lot of, architects, when they come into this, they want something really outrageously spacious and all those things. We as a civil engineers always get squeezed with the budget constraints, the timelines, and all the other things, okay. So all these finally will translate into this, and they have their own challenges in terms of space, they want to see and all those things. In this part of the world where cost is always a driving factor, so my architects are never happy with what they design. Similarly, this is some finishing, I will quickly. Now, the other important part is passenger life safety. Now, this is something which we really need to understand a little bit more. There are, pedestrian flow modeling, some computational fluid dynamics and all those things. We use all these things to make sure that in 6 minutes' time, in an underground station, my last passenger reaches the point of safety, which is concourse. And from there, it's safe to go out. So these are some of those things. I really need to show you this one. नहीं चल नहीं रहा नहीं यहाँ पे आ जाओ प्रेजेंटेशन मोड में सर यहाँ तक हाँ yeah, but it takes a long time. You can see, you can see how the passengers, these small dots you can see, they are all passengers moving from platform to make sure that everything works in line. You can see the timer running and all those things. We have to do this. We have to do this to ensure that, the amount of passenger flow which we are given. Otherwise, once we see that capacity exceeded, we will stop people coming, going inside and coming out of it. So these are some of these things. I better skip. So all the videos are with him, so you can see it if those who are interested. Next one. Okay. So now let's see what happens when the train goes into the tunnel. Now we have this train subway. So this is a downcast. This is going down. So we are having this so-called subway ventilation. It's a piston effect. You take the air. As the train moves, it sucks and throws the air out and make it cool. Now, if this doesn't happen, what happens in London Underground? We are cooling the tunnels now. Why? Because when it was built, nobody thought the clay surrounding that will really become so create a thermal isolation. So heat cannot go in the ground. So the temperature of the tunnel started increasing. And what happens is, most of the signaling in the tunnel can't work because the temperature was more than 40. Inside London, a cold place, the tunnels are so hot. So with all these things, we do these simulations. We look into the conductivity of the thermal conductivity of soils and find out what really we have to do for this sort of things. Now, let's look at, we have a direction of train tunnel, which is coming from there. This is a plan. So you can see 1, 2, 3 coaches. So we have to put tunnel ventilation system. So this fans is throwing air here, so passenger can come out of the train during fire and go back to the last station. Similarly, vice versa here. So these are, I will skip some of these slides. This is Howrah station we have designed for UG1. So these are a lot of fire and platform scenarios, similar to the one I've shown you. Some of these things, again. So this is how, when the train is on fire and it is reaching those sort of a thing, what happens, train fire scenario when the train is on a fire is coming to the station. So how people will get out of it. And similarly, that also, I will just skip it, just of lack of time. But we have to do all these simulations to see whether whatever we are designing is that. So now this is completely very advanced computational fluid dynamics from mechanical engineering people. So this is something, in Chennai Phase 2 extension. We have been given a role, and we worked there for 10 years of Chennai Phase 1 extension followed by 2. We were able to save a staggering, 25,000 crores. Chennai Phase 2 was 88,000 crores. How we did that? We saw that there is no way we can get the land. And to take out the congestion of the city, we have to build a station there. It has to be underground. So let's squeeze it. Let's find a way, solution to what we should be doing it. So we came up with a compact station concept, use the concourse of underground stations, use one side TVF. Otherwise, each station is having 2 sides. Use with new technology, the regenerative braking and all those things. So the UP shaft and all those things, So one-sided TVF system. Normally in underground stations, we have both side TVF. So we provided only one side TVM connected with a bypass tunnel, which is undercraft of the below the platform, a duct for that, and use nozzles to flow this. Now this is getting a global recognition. And it's completely done with us. And we were able to do this. So there are many challenges for alignments and all those things which we do it. So I will also try to skip this. It's just too much detail. There are a lot of newspaper articles as well on this. So now energy optimization, also sustainability, also what really drives it. It's very important. Because fair works collection in India is always very low. The capital cost we are spending and the return, to reach a return to maintain this is very high. So we try to optimize the optics cost. So you can see a traction 80%, non-traction 20%. This also is getting reduced now with a lighter rolling stocks, efficient regenerative brakings and all, and all another 20% for stations and all. So in this, really a SCADA, a control, what is required, what is not required, LED lights and stuff like that comes into play. So this is the I will say, the nerve center of the station control. Tunnel ventilation, air conditioning, all is controlled by IoT, sensors, when to switch it off, when to switch it off, and all those things. So these are some of those generic things, how that works. I'm not going into the detail, but it's that everything has to be centralized and controlled, and people can see. But there is a lot of things to be done on this, particularly related to cybersecurity. Recently, we heard a lot of things, how we can improve with this sort of an open set of data, and what we are going to do with this. Now let me come to the tunnels. Now I'm talking about only mechanized tunneling, though there are many types of tunnels. So we have a first is look at the alignment, look at the geotech, select the right side of a TBM. So we have many classes of TBMs, different TBMs has a different properties. So we can't, this is a Mumbai line 3 TBM. Now let's look at the art involved in tunneling. Segmental lining is one of them. Universal taper. Because my TBM is a cylindrical box, a rigid box. When it bores through, it will go up, down, this. We use sensors to see where it is going and how we can rotate the rings to, like a screw, to make it align and gradually come to its path. So that's this all system. There are various systems, I'm not showing it here, which is, what are the purpose of the gasket? In case the gasket fails, what happens? What is the purpose of this caulking groove? How we put jack? I'm not doing it. I'm just looking at some of the logistics required and how much engineering goes into this to lift, stack the segments, to steam cure them, to do a lot of things, demold it, because we just can't wait 24 hours to demold it. So these are some of the steam curing things, which is what extraction time and all those things. We use a vacuum cups to take it out and demold it. These are some of the cross sections of the tunnel. You see, so many services are running as railway safety. This is the final article, and that is what it is. And now, look at the challenges of urban tunneling. As we know, by maybe 70% of Indian population in 10 years' time will be reaching very next to big cities. So we are building a lot of infrastructure, and while existing infrastructure is also getting crumbed up. So this is the Calcutta Metro. The top photo is this one, Baboon flyover. If you come out of Howrah Bridge, try to go to Esplanade, so this is, you have to cross this. And this is normal traffic. And this was closed because we were doing tunneling here. Just below the piles, this is a flyover. So imagine it, we really rely on all these things to monitor, to see. We need to have not only on our engineering, but we have to have a big confidence on our machines if they are going to do it right. So this is approximately the C, Mumbai line 3. These are some of those conventional stuff, cut and cover, all those. These are sums, which is a lot of time and energy we put to build this, because they have to be connected. And this is, again, Calcutta. This ventilation shaft is next to Hooghly River. And the Howrah station is 750 meters away from that, because this is the location we have to do. Now, during construction of this shaft, this particular shaft, you can see this is a connection to the tunnel build. During construction, while we were doing here, suddenly there are all buildings around this place, old Calcutta. We realized that one of the diaphragm wall panels has given up. And there is a large amount of water with those things started coming in. I got a call 4 o'clock in the evening. And it was a very, strange. They were showing me a video call. On video call, they are showing me, look, what's happening? Oh, this strut is giving up. And the last sentence I heard from the project manager, please take a first flight and come. Immediately, I started going there. But what is the solution? Building started tilting. All the water. There are 2 tracks around this, railway tracks. It was a big panic there. Finally, some of my old gurus, it was a Singapore Bugis junction. I remember that he was telling that we learned this underground excavation through how we make coffer dams in the sea. And that clicks. I said, bhai, please put all your 35 horsepower pumps in Hooghly and pump the water and fill it up. By night, this was full with water from inside. So it balanced the earth pressure, the settlement stopped, and the crisis was over. So we as engineers just have something, it was just came to my mind, maybe it is my destiny, but these things do happen. And most of the time, even, if you visit any European site for tunneling and all those things, what we do is Vishkarma, before we go into the tunnel, they also have they call it Saint Barbara. Every modern, they put it. They know that we never know ground till we are in. So this is one of those examples. I'm sorry, I'm just joking. So this is, again, Hutatma Chowk. This is how it looks like, and this is, over the top of this is downtown Mumbai Cafe Parade, and we are digging this Netam tunnel, basically below a Parsi's temple. Thank you. A Parsi's temple, and the secret well, their sun god, secret well was just above that. So the amount of engineering we have to do to make sure that, उनके उससे पानी नहीं निकलना चाहिए, was amazing. So with all these sort of photos are there, and so this is another type of thing. So, and thank you all, and this is our time confidence drive. Thank you.
Excellent presentation. I would like to call Professor Wangla to give a token of appreciation for gracing your presence to this event. Okay. So now we will proceed towards our panel discussion. And while we prepare our stage for the panel discussion, let's take again a small trivia question. We have talked a lot about tunnels, so let's take a question on tunnels. So Thames Tunnel. Thames Tunnel is believed to be the first known tunnel to have been successfully constructed underneath a navigable river, which is River Thames, using the newly invented tunneling shield technology at that time. It measured around 35 feet, about 11 meter width, 6 meter high, and was about 396 meter long. Can anybody guess how many years it took to build this tunnel? Huh? Sorry? Huh? Yeah, just give it a guess. Just think how much time it would have taken.
18 to 20 years. 18 to 20 years.
say one answer. 18 to 20 years is a lot of time.
So it will be higher side, 20. It's 180.
Either it would have taken 18 years, either it would have taken 20 years.
From my side, you will take 18 years.
18 years. Anybody else? Huh? Have you used ChatGPT? Huh? Not now. Earlier. So exactly it took 18 years, in fact. So, so it took 18 years. It started in 1825, got completed in 1843, and it opened after 18 years only for pedestrians. And then they because they ran out of money to, so they couldn't afford to build the ramps to get the cargo inside. So it took another several years before they started having this tunnel for cargo. And in fact, at that time, it was considered as the 8th wonder of the world. So that is a small history about Thames Tunnel. So now I would like to invite Professor Wangla, who is the moderator of the panel discussion, to take over the dais and proceed with the next session. Thank you.
Thank you, Sumit. Before we start this panel discussion, I would like to give a brief background or the genesis of this panel discussion. I think now we have already seen 2 presentations from the industry, and which were very fantastic, and which gave you some idea about what actually the industry is looking for, right? So the panel discussion is a follow-up to these presentations. What we thought, we should have a group of esteemed experts from different domains, and where we frame some questions before the meeting. So we have framed few questions for this panel discussion, which basically helps us look into some different aspects, like for instance, how we can bridge the gap between the industry and academia as the innovation accelerates like Jupiter gravity. So we have to really look into the important aspects that includes how this theoretical knowledge, what we learn from the academia, can be applied to the practicals, which is again very different when we think practicals from our side. The industry has different practicals actually. And then how we can foster the relevant collaboration and also look into the real world problems and in the solving, and then how we can develop the workforce readiness from the students. Okay. So with this, without further ado, I would like to invite our esteemed colleagues and the experts who have come all the way. Some of them have traveled all the way from Maharashtra as well. So we are really happy for that. And with this, I invite in an order. So first I would like to invite Sri Parthasarathi Cheru, a Program Director, Infrastructure Niti Ayogi. And now I request Dr. Atul Nanda, a former Engineers India Limited employee. And Dr. Nitish Gupta, Chief CTO, who had given a wonderful presentation right now from Sistra. And Sri Ravi Sundaram, from Director, Sanjars Geotechnical Private Limited. And Sri Govind Raj, Deputy General Manager, who flew all the way from Maharashtra for this event. We really appreciate that. Thanks for doing it. And Keller, he's from Kamal. And our well-known faculty professor J.T. Sahu. And I put my introduction very limited to this because all of them are well-known. And with this, I would like to keep some housekeeping items here. So this session is for 30 minutes, and we have 3 questions. So each question we want to give 10 minutes, and the 10 minutes includes opinion from the experts and maybe 1 or 2 questions from the audience. I hope this is clear. Okay, with this we'll begin. And the first question, I'll be coming there, and I'll be from there. I'll be there. Yeah, this is the first question, and the question that basically that we have already shared with the experts but I want to let you know. The first question is industry academia collaboration. The question is, how does industry look forward to collaborate with academia through internships, joint projects, and partnerships to foster innovation, talent acquisition, and future readiness? And there's one more question in that. What steps industry is taking to hire and retain highly skilled PhD talent? So with this question, I would like to start from here, this from the right side of my, so you can start.
Thanks. I'm from Keller. We are an engineering. I'm from Keller. We are an engineering contracting company. So we are having a program, dedicated program like a YEDP, where we recruit people from different functions, and we train them, and based on their expertise, actually we will be keeping them in different departments. So this is one thing what we are doing. And the second thing is, every year we are providing some internships to selected students, and we will be keeping them either in office or in site-based. Then, as a part of the CSR, our CSR activity, we are providing scholarships to the geotechnical engineers, especially those who are coming from less privileged category. Those who are having financial troubles, we are doing this. And another thing is, we have frequent visits to the colleges, we provide the guest lectures, we interact with the students. So this way we are actually trying to bridge the gap between the industry and the academia.
Thank you. So now I request Sri Ravi.
Second question or come to second question?
Second question, yes, yeah, if you, yeah, please.
Okay, just I will continue that also.
Yeah, please.
So, so like what I told, we are engineering contractors. We design and we execute. Then we, during the execution, we see how the quality goes. So for us, the innovation is very important, but we have time-bound projects. So the research is only so it cannot be that we do lot of research, because definitely our head office do the research works. But since we have time-bound projects, we have limited space for the research work. But at the same time, we ensure that we have very good team around. For example, for the PhD point of view also, see, if I am just talking about the Keller North and West unit, 2 units, North and West, we have the people actually who running the show are doctorate guys from IITs, from North and West. So we try to keep a proper mix of doctorate people and along with the MTech geotechnical people. Yeah, thanks.
Thank you. So, Sri Ravi.
I am Ravi Sundaram from Senjas. Our company, our main thrust has been on investigations. Now, as far as industry academia interaction goes, in India it has been at a basic level, not too much, because what we also found many a time is that the industry academia interaction, both sides have different perspectives, and unless the two meet properly, that kind of a association doesn't build. So as far as the academia is concerned, they are more interested in, generating PhDs, generating technical papers, but in the industry, the thrust is on innovation, data analysis to be able to get the right kind of interpretation of results. Can you save some money for your client by interpreting your data differently? To be able to bring these things on a common platform, what I feel is that there needs to be a little bit more open kind of interaction. Internationally, I find these things happening. For example, Peter Robertson takes data from these companies, and he does his interpretation, and it's not that, you give the data to a bunch of students who are finally the output will be a PhD degree. How has it actually benefited the practice? That's more important. So I feel that you need to change our perspectives and start thinking in a way that would definitely benefit the industry. Then industry is ready to come forward to, spend money and do things. Thank you very much.
And just to add with my background, I did my PhD from Saitama University in Japan, and I was really aiming to become a professor or join some academia, and that's where I was going. Then finally, reality strikes, where I'm going to get a job and all those sort of things. So I have two choices: to go to US at that time, hot Java and all. I can do good programming, so I've been offered that I should just jump that and go. The second was, last moment my professor told me, you are a good researcher, so you go and you will do whatever, you are also good engineer, you can go anywhere and you can make your livings. So then he got a job me in Singapore, and I went there, and the first thing, what I did after a PhD, doing a survey next in an open sun, because that's how the Japanese start. 6 months survey with theodolites and all those things, and I don't know what is a theodolite. I have to read myself and do it all. And that's, precast yard, how to handle this and all those things, make me realize that, okay, I am first engineer, my fundamental degree is civil engineering, and let's build on that. And other things also, as long as I have the ability to learn very quickly other discipline and do whatever is required and solve small problems, make the life easy for the engineers around, I can get. So they call me most of the people in Singapore, they thought I am a medical doctor. So that's their understanding, because I'm working with Thai workers and all those things. For them, doctor is only who gives. So some people also came for a prescription to write, Karo, Dr. Saab, So, but having said that, no, that was a very interesting turn on my side, and I realized that possibly I can do it. And doing a immersed tube tunnel, just a very quick one, means I'm just trying to tell this, summarizing it. Immersed tube tunnel, looking at, even in India, I have never touched any sort of a welding machine, and now welding on a height of 20 meters above the sea level in the night. But since I have to do it, I did it. So unless otherwise you are not able to step out of your comfort zone, and everything, please remember, everything is, always there is a marpit at the bottom of a pyramid. Once you go up, it's all free. So it's all about where you want to reach. So that's I learned my hard way, but just be versatile. Don't get scared with, as long as you have a knowledge and you have a conviction with the fundamentals, some ability to think from first principles, you will be all right. Knowledge is always good. It's great. Okay, so that's all.
Dr. Gupta, just I want to ask something. What Chestra, as a company, doing these kind of joint projects or internships, some innovations, and how welcoming is your company for hiring PhD students with a background of geotechnical engineering? Can you just add some?
Okay, yeah, that's sorry, I did not answer that. Look, we hire good engineers.
Okay.
Doesn't matter for me, they are PhD or whether they are from a site. Okay, so and that's a fundamental. Any degree, if you come with something that I'm a bar bending scheduler, I will hire him. Because I know he understands what is bar bending, at least he will make less mistakes in issuing the drawings to site. Okay, so that's very clear, and always knowledge is good. I'm a PhD.
Yeah, that's right. That's the reason.
So
just one more. Sorry, so your PhD you have done on some topic, right?
Yeah.
Now you are working for a company that is completely having different disciplines,
Yeah,
different
yeah,
domains.
yeah.
So now how can you add some lines which would be encouraging for these PhD students if they want to pursue this industry career? See, they always have some insecurities, like, see, okay, I did my PhD only specific topic. Whether I can get a job for that particular specialization. So what are your tips and suggestions to overcome such stigma?
First thing I will just suggest, once you have done a PhD, please believe in yourself. जहाँ भी जाओगे अच्छा करोगे. As long as you have that belief, nothing is going to stop you. I'm sorry, I'm just getting a bit emotional on this. So, and these are the questions. I also struggled a lot for this. So. So don't get afraid if you are a PhD to step into unknown domains. You will be all right. That's all I have to say.
Thank you. Thanks a lot. Sir.
Good afternoon, everybody. So, looking for the opportunities for the geotech engineers for internship as well as for the employment opportunities, I look at this way like create the market. So don't just be proactive. You can create the market. Say if you look at the way that Viksit Bharat 2047, like developed nation by 2047, we had Professor Bhandari and Mr. Sundaram highlighting the importance of geotech engineering in infrastructure development. So geotech is there in all parts of infrastructure sectors. Okay. Now if you look at massive investments are happening in infrastructure domain in India. Like for example, if you take this year, there are 11 lakh crores of public capex is going to the infrastructure development. 11 lakh crores public capex and another 4 lakh crores from the PSUs, similar amount from the states also. So if you look at this way, almost 25 to 30 lakh crores is going in the public capital expenditure to the public sector. I'm not touching the private sector. So this is the level of investment that is going. So if you want to meet the aspirations of the people, be a developed nation by 2047, so massive investments will flow into the infrastructure. So most of the infrastructure either will be upgraded, rebuilt, or a greenfield infrastructure will be developed. So going from the sectors, we are moving from 2-lane to 4-lane, 4-lane to 6-lane, 6-lane to expressways. And even otherwise also we are moving from the access control highways. So this is the investment that is happening in the highways. So where the geotech is coming, you are facing huge challenges in terms of building the highways in difficult terrains, northeast terrains, hilly terrains. So the subject that was handled like you can control these, you can predict the landslides, you can control. So these are the areas that need to flow into the industry. Other sector like ports, where geotech is once again there. Now we are building Vadavan port, that's almost 75,000 crores of investment, 23 million ton TEUs capacity, which is equivalent to the entire container handling capacity of all the major ports present in India. That is the massive investment is going to happen and massive capacity. There are also once again the opportunities. Similarly, you can have the airports, you can have the railways, be it the metros. So whatever the metro that right now we have, it's limited to some cities. Wherever in Delhi, the network is keep on expanding. Once you taste it keep on expanding. It will never stop. Similarly, more cities going to get added. So these are the opportunities that geotech engineers will be having. The another thing what I will say is the pumped storage. So if you are going for the huge potential in the green energy, pumped storage will play a key role in terms of stabilizing the grid. There also once again geotech engineers. So here what I would like to say is you have to create the market, you have to create opportunities, you have to identify the areas where geotech engineers can add value in all these areas of infrastructure development. These projects and these programs are visible and you have to create the market. To that extent, I think IIT Delhi can take a lead and have a core group of the people working on the subject, and they will be looking for the opportunities. They have to create the projects and take it to the industry, take it to the government. Yes, these are the areas, and I can assure you that no one will say no to these type of interventions, and funding is not a issue today right now. And not the least, I think whatever the development, whatever the projects that we are going to handle, I think sustainability is the key aspect. Even we have to see what is the level of GH emissions that will be involved in development and in all the process. That need to be kept in mind. So that will add value to our process. So I think this is how I'd like to say in terms of PhDs. Okay, so once PhDs is a continuous process. Let the PhDs not be an individual project. Let it be a programmatic approach. Let us target what are the technologies, because at the end of it is the technology that is going to drive the future. Okay, we need to create the technologies not only for India, we have to create the technologies for the world. If I have to create the technologies for the world, think ahead in the 20 years where geotech engineers should be there in the next 20 years. And from now onwards, we have a programmatic approach. It is not only geotech engineers, you have to have other civil engineering fields and other instrumentation engineers, you have to data engineers, everyone has to be there. And you have to clearly having a monitoring mechanism, and you have to every year you have to have the targets and outcomes need to be evaluated. I think this is the way we can make the PhDs really work and contribute to the economic growth of the country. And if you look at the Niti Aayog, as such provides a huge opportunities for the internships. So every month we'll be having almost 200 interns working in Niti Aayog. They will be working across various domains, social sector, infrastructure sector, in science and technology sector they are working. So this is a huge opportunity and everyone knows about it. You can apply from the 1st to 10th, the slot is open. Anyone can apply and they will get their offers in the same month. And for the experienced people, it's always website is always open. You can always submit your resume, and based on the requirement, they will be called for the interview. It is 24 hours round the clock, and throughout the year, the website is open. Like there are opportunities in terms of based on your experience, young professionals, consultant grade 1, grade 2, and senior consultants. The positions are open, and you have to submit your resume, and you will get the call based on your experience. Thank you. Thank you. Sorry, I took a lot of time. I just wanted to give.
Maybe just one follow-up question. See, I'm taking the side of private industry and researchers here. Researchers, when they do PhD, they come up with the innovative ideas for implementing in the practical. So how well the government welcomes such ideas to implement in the field, because we work on different projects and we come up with the different methodologies or technology. So how welcoming would be the government, and what are the hurdles that basically one has to go through to really see the implementation of whatever that is coming from the research lab and then through the private industries?
See, look at the way in the previous presentations I had seen, you are working with Indian Railways, you are working with DRDO, you are working with the Department of Science and Technology. So most of the organizations you are already working, okay? So if you go with an innovative idea, if you're going to solution, like railways, you have provided that, or the damping solution to the track.
Yes.
It's a wonderful solution. Almost you are taking the Indian Railways to the high-speed rail level, actually, the type of comfort cushioning that you will get in the high-speed rail you are going to provide. And also from the, you are going from the bridge, once you are entering into the cutting area, definitely that is a normal engineering that you will be having, you have to address that. Once you address that geotech grid, like black cotton soil and all those things, where you will be having the issue, so geogrids. So what are all the solutions? This one solution will immediately be replicated throughout the Indian Railways and in highway network. The replicability is huge in India, the opportunities. And I don't think right now for you have really a good idea, good research idea. I think you have huge opportunities, and like the focus like this budget also you may have seen. There is on the research and innovation, there is a specific focus on the research and innovation. Various programs, various schemes are going on research and innovation, and one is AIM. You must have Atal Innovation Mission. So it's already there is housed in Niti Aayog. I think you have to be proactive. That's what I can say.
Thank you. That's really encouraging, because I just want to let my students know that yes, there is an opportunity that we have to utilize. That's it. Thank you. So over to you.
to work for EL a long time back. I used to practice.
It's just good.
Okay, okay. It's clear now? Yeah. So I used to work for EL a long time back. I used to practice engineering probably in the Stone Age now, compared to all the youngsters around here. So I'll just share some experiences. In our time, we would learn theory in college. You joined practice, and as you forgot your theory, you went up the ranks. And when you had forgotten everything, you became the boss. So that was the old system, okay? Now, it's changing, okay? And it's evolving, it's changing a bit. So I'll just share some experiences. Like normally, interaction between academics and industry will usually happen when either they face a problem or when something new comes up, okay? If you look historically, when things like computational methods came up, they could only do it in places like IIT, okay? Now it's quite common, okay? Otherwise, what happens is when some society faces a challenge, pollution, waste, like you have developed all that geo-environmental stuff in IIT. So if you have to look at where are the possible areas, we have to look at the challenges and the technologies which are coming up now. Most of the technologies will come up in adjacent fields and they need to be adapted. Challenges, very clear. Energy transition. It's a major challenge coming up. We are going to evolve and change the energy system of the economy. Energy is at the heart of the economy. So everything will change. And in India, we not only have to take energy transition to reduce carbon emissions, our economy is growing so fast, we even have to rely on our old fuels. And most of our fuels are imported, okay? Oil, 85%. Gas, more than 50%. And they are going to continue to increase, okay? How do you handle this thing? Energy security on one hand, energy transition on the other hand. Here, geotechnical engineering, vast opportunities. Underground space, cheapest method. Economy, security, safety. How do you store them? How do you store oil, gas? Okay, hydrogen, green hydrogen is coming up. Compressed air, okay? Renewables are intermittent. How do you handle when there's no sun shining? How do you get your power? You can't rely on batteries. Pumped hydro is one option. Compressed air storage underground, another option. So there's huge opportunity just in energy transition itself, okay? And so the best thing is regarding hiring of PhDs. So if people are working in areas which are coming up now, automatically industry will have no choice but to take those people. So these are my few suggestions.
Thank you. I appreciate it.
So most of the things have been told by the speakers, and I'm from academia, so I would talk about from the academia point of view. I know that it is, means from our experience, I can tell that it is very difficult to get any data from the industry, let alone from the private, even government industry you cannot get the data. And even if your boss tells, that means ministry tells their officers to provide the data, they won't provide. Because, and they can provide very good data to you, which is giving very little settlement and everything is very nice, but they will never tell you about the failure or access to settlement or the water gushing in, or they will present in here in seminar, etc. So I think my suggestion to all the people and the government officer is that you create some system wherein people do not feel very shy of providing the data, because unless you share the data, how the academia and industry of our country will progress. That's my suggestion.
Thanks a lot, Professor Sahu, for the and I think we had good discussion on the previous question. We can take quickly one or two questions from the audience, from the students.
Take more.
Yeah, I mean, like, see. So, okay. I mean, in the interest of time. Yeah, definitely. Please, I would be happy. From the students first, and then. Okay. Yeah, please.
Am I audible? Yeah. Sir, actually, I am in between the academia as well as in industry, because I am an industry professional and now I am willingly choose the one course as an academia student. So there is a one question which always striking in mind, because most of the fellow here is a geotechnical fraternity which belongs to civil engineering or somewhere. This question is particularly with the industry personnel like Nishit sir, as well as governance like Reddy sir, that why we are not raising our funds when we have a 25 lakh crore of capex, then why we are not giving to the people who are going as a fresher coming from the MTech, BTech or PhD to them. We are just fixing the amount of 25,000 or 40,000 rupees to them, which will be somehow parallel to the stipend coming from the PhD. Just like in European countries and American countries, where the people who are pursuing the PhD, they are willingly go over there because they have a handsome amount of money. So if we are making such a cordial environment where the people who can go in a higher studies will get the right remuneration as well for their entrepreneurial skill as well as the technical skill. So this question is always comes in mind, and since this is a very delightful panel in front of me, so I cannot skip this opportunity to ask this question. Thank you.
So we are from a private organization, and we are contemplating to do this. We were in talk with Professor Ramanna, and we are trying to create a sort of a things, where we can engage people. Just the interaction with academia and the practicing engineers makes a lot of difference, And so we are going to, we have a program for the coming year to roll out all those things. And that, I'm very clear about it, that there has to be somebody is putting his prime time of his life into this sort of a things. He should be suitably compensated, And that is something, consulting engineering is, we have a very small value in terms of, we are not contractors, So that becomes sometimes a bottleneck, If you are not happy, with the sort of remuneration we are going to offer, obviously, there is something. So unless otherwise we have something. And that's why I also, I'm talking to Professor Ramanna, we did some brainstorming as well. I will suggest to be a bit of a, once you are doing a PhD or a higher studies, be a bit of a multidisciplinary. These are very simple things, Mushkil nahi hai kuch. So as long as you have that and you go and tell, please offer me a job, don't worry about it. The way I go and talk to the clients. Agar you give my company this job, I will do a value engineering for X percentage. How you will do that? If you have some good answers for it, you get a contract to do that consulting engineering. So have that, things, and industry will love to. But this has started to, as he rightly mentioned, through the government companies and things like that. We have to invest as a community to the research. That has to be there. Somehow it is not really coming up, The government can't do anything. It has to come from community as large. Whether it is a startup ecosystem or whether if the company hires somebody like you, he should get some concession on any forms. Say for example, we have some CSR funds, But there are designated to only few things for a specifically which is sustainable goals. Only then we can give you that. So there are a lot of restrictions from that. So whenever I get a chance on some policy making forums, I do talk about that as well. And I hope something will happen. Thank you.
So just follow up to that. Let's say like some of our students from masters or PhD do internship with your companies.
Yeah.
Okay. Would they have higher, good chance of getting good remuneration? Because if they're getting some sort of experience, they're involved in some of your projects, and then they're graduated, and whether your company will be showing interest with high package to that
Look, we started all this exercise just before COVID, but due to COVID, that was shut down.
Okay.
So again, we are going to start that.
that's-
And what we do is any promising things, depending on the skill mappings and all those things, he's, if he wants to be a project manager, he can go and do that. So we will offer him a job.
Okay, that's good.
We encourage people to learn and grow.
Okay.
And Sistra is a multinational company, so we encourage people that if you want to find a job, a suitable role, please take it.
Sure.
The only request we have that people should be willing to move. As a civil engineers, that's the biggest constraint.
Thank you.
Like it is 75,000 starting salary, not like a fresh MTech student. That's what is bothering them. I mean, once they get into it, they can diversify, they learn, with age salary will increase, but they're talking about when they jump in.
That's a question we should take some of these suggestions that, if we are taking a PhD, then all those sort of things. But normally, even with a master's, we don't differentiate between a graduate engineer and master's, maybe just 2 years of experience with PhD, maybe 5 years with master's, 5 years. So that is the level he will enter. But he will find it very difficult the sort of work we do, very difficult to catch up with the younger people. So the way I look at it, as long as my PhD person is, because PhD is basically research, if you go to US, there are multidisciplinary, I will start this research in geotechnical engineering, and possibly I will submit my PhD in mathematics department, So that is something which we have to inculcate in our committee as a large, to really, invest. And it's a simple, it's just, engineering has no limits, it is just simple. Finally, it boils down to very simple strength of material and some mechanics and some second law of thermodynamics. So as long as you are a versatile, you are articulate and all those things, you will rise, but with a PhD, you will rise very fast in the organization.
If he is good.
No, it is, everybody is good. It is all about, everybody is good.
That's a very good statement.
That's how, everybody is good. It is just he's not getting the right slot for his talent.
Thank you. Okay, so with this discussion, as a Professor Ramana, sorry.
Just one question very related to what Professor Ramana asked. When any PhD student applying for a job in private industry, they are always treated as a fresh BTech student. Their experience of 2 years of masters and 4 or 5 years of PhD, these 7 years they are not considering in most of the organizations. So it's not a very warm welcome to the industry. So my question is that any PhD student who are joining to the industry, they have the minimum expectation being a salary in the level of assistant professor if they join in academic. Right. So why this kind of thing happen? And don't you think that it's not a kind of the warm welcome so that they can do the work efficiently by joining to the industry?
So I'll just add a couple of more points in line of Professor Ramana. So what we are seeing is this, that if I compare that if you really want a good product, you should pay for good amount. That's what it is. I mean, all of us buy a Apple iPhone and then we are willing to spend on that, right? So if that is the mentality, so if we see the European nations or the kind of the US, the culture as well, they are paying really good. And this cannot be the mentality in the Indian industry, that if you really want good people, if you want to retain them, people are getting out of the country because they are being paid, whether it's in Singapore or it's in UK or it's the Nordic countries as such, and they are having a shortage of people. Now in India, if you really want to have a boom of industry and revolution which is coming, and infra which is actually catching up, what I feel is that the industry needs to pay them quite good. Otherwise, it cannot be like software IT companies like white collar jobs where the salary is fixed and the starting salary is very low, and if you have to, with the inflation, if you have to stay in a city like Bangalore or Mumbai or Delhi, you cannot sustain in that salary. So that kind of mentality has to change from the industry as well, and that what we are looking forward to, that you would welcome the graduates, the fresh graduates who are coming with a skill set. It's not a skill set that you get from any Tom, Dick and Harry in any nukkar ka dukan, that they are coming with that. They are coming with very specialized skill sets. So that has to be welcomed, and that has to be remunerated. So it's like an iPhone. If you want to get a good product, you have to pay for it. Otherwise, they will maybe working for a couple of years, but then they will run away.
Reality is, I was, I was leading a show of Chennai Phase 1 extension, and there was a tendering pre-bid service, and, and there was a requirement, and with lot of my insistent CMRL puts it that, any team leader should have a PhD, okay? So they put it. So most of our competitors, I will not take the name, they openly told in that forum, in this part of the world, those who don't get a job do a PhD. Now, this is not something, we and you can't shout for ourselves. Though they finally, I gave them a peace of mind, I will not repeat it here, it's retained there, but this is to be there. Why we are having so much things, when you look at, it's a big job. 40,000 crores, 25,000 crores. But these people are, when you look at the PMC, there is barely on the technical qualifications of the company who are bidding for it. So, so it's a very, very different, it's all about from any, I was very surprised when I went to Japan that nobody knew where is New Delhi. And, they treat us from somebody, Bangladesh, India is all same. Oh, I went to India and, I got bitten with this, I went to, plague and all. So, no, situation is bad, I'm telling you.
But I'm sorry to point it out. I don't really agree to this point. I think with the Prime Minister's vision, what we have, and throughout the world, this notion of India being back foot and all this thing has changed. And what our legacy has completely been changed, and it is being, carried out throughout the nation, that it's gone are the days that we are going to listen to the first world nations as such. So we are changing, and I think the policymakers from the Niti Aayog, they can also talk about it further, because our notion as the whole in India, all over the world, it has changed completely. It's not gone are the olden era that we are being controlled by some Russian or some other people. It's not like that. It has changed completely. Even people are taking us very seriously when we are talking about it, whether it be the European nations, whether it's France, I have been there as well, or it's in US. So I really am sorry I don't agree to that.
Let me just give you a few seconds to answer him. And just, I am talking about, I was talking about in 1993, okay? So that was the time, and now it has changed a lot. But still that old mindset is very difficult here.
Maybe just to add on, tell the participants, so even if a doctorate grade, he joined. So the reality is, even if someone after PhD join an organization, first 1 or 1.5 years he will not be able to perform whatever academic excellence he is having, because the industry is something different. So nearly because we have seen it couple of times, 1 to 1.5 years he will not be able to perform. But the same guy, if you are just comparing with a 7-year-old experienced guy, so by that time he will have very good expertise in that particular domain. So this is the one reason why companies are little bit reluctant to take the doctorate people. But actually what is happening is that now system is changing.
So
Now what is happening that with the initial years, actually we shouldn't have the instant gratification. We should have little bit patience, especially the doctorate case, because after some 2-3 years it will be completely reversal. Because if someone is patient, maybe in couple of years they will be able to climb the ladders very fast than a normal geotechnical with the engineer with MTech. But the first 2-3 years, companies are not getting anything back, to be frank. But and there is no surety that they will be continuing with the same company. So this is one actual practical reason. Means it's practical.
So in continuation to that, actually, we have the second question, which exactly talks about the bridging the skill gaps. So what is that? Now the problems have been really highlighted here. So what skill sets, how that can be integrated with the so that we can bridge this gap and help the students to get the good salary and progress as compared to the experienced. So continuation to that.
So now I think you want.
So I have to just leave after this immediately because I have to catch a flight. So I will just answer this thing. From my perspective, I want to say that first thing is I agree fully with the previous speaker from Keller that salary initially will be less for PhD. Believe me, in 2007, my first student, I must say everyone is good, as he mentioned. So he got, Datta sir was there, he was in the panel, he said कि आपके student का थापर में selection हो गया है. To my surprise, he said, sir मैं वो नहीं जाऊँगा academic, मैं जा रहा हूँ industry में. उसने industry join कर लिया, कोई industry join कर लिया and it was not much salary. That was in 2008 he joined. 2014 mein he had 25,000 rupees salary, 25 lakh rupees package from L&T. And still he left that, he started his startup. Then he moved to London. Now he is going to US. So everybody is good. PhD rise very fast. Initially you may get little less, but your rise will be faster. That is one thing I want to say about that. Second thing is about the skill. What skill you have to have. See, I am now just celebrated my birthday few days back. This month, 60 years. I am 60 years old. But still, I am reading the books, I am calling the books and buying the books of the RCC. I have to refer the RCC code. I am very happy, man. Some people are working with me on tunnels and they said उनको जान के RCC देखने में थोड़ा लगता है यार कहाँ भूल गए हम तो सब लोग. तो अब कहीं कुछ भूलना नहीं. पहले you are civil engineer, you have to nurture that. If you work on geo environment, आपको hydraulics आनी चाहिए कि water यहाँ से इधर flow होगा कि इधर flow होगा, कहाँ से निकलेगा water, नहीं तो फिर पूरा आपका bridge, आपका पूरा landfill failure हो सकता है. So there are a lot of things you can't forget. The second thing I want to say that you need to have some kind of a engineering sense of the things. For example, somebody just took बोले कि भाई program run नहीं करता है Plexus का, तो cohesion हम 10 kPa लगा के run कर दिए सर. वो loose soil silty उस पर 10 kPa उन्होंने लगा दिया, सब कुछ run करेगा. मैंने बोला यार 1 kPa लेके आओ उसको. तो कुछ सेंस होना चाहिए. मैं एक जगह PhD के एग्जाम के लिए गया, वहाँ पे they were doing analysis and they were taking only C. बोले 5 हमने 0 कर दिया सर, वो C लिया है. तो C में तो सब कुछ सब सही रहेगा, कुछ नहीं होना अल्लाह फेल्यूर. तो these are kind of some of and this can be developed only when you work on some live project, some failure case studies, some problem in the field. And third thing I want to say is you go to the field visit, look at the site, look at the failure cases, site visit is one thing. But when you go to the dam, try to go inside the turbine and see what happens, how is it made, what is the size we are talking about. किताबों में बात अलग है, but you have to go right in the heart of the problem and see that. And third thing, the most important is you must learn how to think. So I like Datta sir because he is very good thinker. One must think in that line of thought. किस तरीके से आपको problem को confine करना है, उसको develop करना है, and then you have to bring up the solution. So these are some of the things you will not learn unless you classroom में बैठ के नहीं होगा, लेकिन you have to keep developing these things. This is my suggestion. Thank you so much for your attendance.
I think your question the answer also to largest I think should come from this query. Like if a student who has completed BTech and if a student who has completed MTech, if a student after PhD, that means 2 plus another 4, 6 years, if all of the 3 are being provide the same package by the industry, that means that there is a lot to be done by us, including the IIT also, including the IIT. So what is that industry looking for and what are we equipping our students with? Okay, that gap we need to fill. So they need to see the value, a student putting additional 2 years here, whether he is acquiring additional skills so that is enabling them to pay additional industry. The same thing with the PhD also. I think it's not going to happen. It needs a thorough, maybe IIT may work and we'll be happy to work with you also. Maybe you have similar industries, similar sectors where the packages are much higher for the similar type of student, and why it is not happening here? Is it a supply demand gap, or is it not the market is less? For example, in IT we have the global market. Do we have such type of market here? Are we able to create such type of global market for our students? Or what is that? So we may have to have a detailed analysis and comparison and what needs to be done. I think it's not something difficult to be done. I think in a timeline, I think let us work on that and let us address the problem. I think that can be solved. I think it won't be difficult. But industry also need to see value in terms of the additionality value, in terms of the students, the skill sets that the students are acquiring during this period. Thank you.
So can I make a point about good and not good? You know, because everybody is good. I think the industry is basically losing good people because they get diverted to other places which give better salaries. Let me just build on what I'm saying. 5 years ago, you could do a PhD and go to a private engineering college and get 80,000 rupees. Period. That was something which was available. I don't know whether the number of colleges has decreased and these things have come down, but there was an alternative. And the industry would not offer that kind of money. So where did the people go? They get diverted. They are not going to come to you and wait for 3 years to see whether you're going to give them more. So I'm saying there need to be some benchmarks that if a guy is good, you should have the wherewithal to discover him, be prepared for the fact that he'll take 1.5 years to get to the mark, but your benchmark must be visible, na? L&T, Keller, their benchmark should be visible, that after 2 years, if you're a good guy, you're going to get a couple of lakhs of rupees. So I'm saying something else. I'm saying, okay, BTech is the same as MTech, is the same as PhD, or maybe a marginal difference. But the difference cannot be low. Otherwise, what is happening is the industry is losing the good PhD guys to something else. Is there something else, another teaching institution? Is it going abroad? Is it going into IT? The industry is responsible for it. If I have a good PhD student, and if I give him a very high recommendation, I expect the industry to recognize that, to pick him up and treat him like gold. If you're not able to do that, that's your problem. And that's what's happening. And saying that you will only grow when you get the gold PhD students from IITs. They will all be able to perform what you want, and they won't be costing the industry much. So that benchmark has to become visible. My BTech student must see that if I do an MTech at IITD or a PhD at IITD, today I'm getting, let us say, 30K or a package of X lakhs. If I do a PhD, just like if I do an IM, my X lakhs become 7X lakhs or 5X lakhs. they must also see that if I do a PhD at IIT, then it must also become 3 or 4x. And that will motivate even those guys na, कि जिनको नौकरी नहीं मिलती वो PhD में आते हैं. But it will also motivate the guys who see that they can go X times into the industry after they come and do a PhD. So it's a give and take thing, that's what I'm trying to say. But the benchmarks of PhDs passing out of IITs in the industry somehow need to get established, at least by the major players.
Stop saying isko naukri nahi milti PhD aata hai. I think we should stop saying that. I think that is
No, but that's what was said in the panel. That's what I said. No, we can say.
Yes. Yeah, the skill gap. Actually, if you have some more points to be added to this, bridging the skill gap through some different modes, yeah, please. Sure.
The problem is the whole engineering education from undergrad onwards is all analysis based. Okay, the stress is only predominantly on analysis, very little on design. Okay, so this thing has to change, and nowadays there are a lot of techniques available, project based learning. Okay, a lot of things like that. If they are more adopted, and especially you have a mix of analysis and a mix of design. This will help the absorption of people from academics, no matter what the level is, MTech, PhD, in that. So that is a significant part. The second point I want to say is MTech is the basic degree for geotechnical engineering. So we should not over-specialize in that or narrow it. Cover soil, rock, everything, okay? Even some geology, okay? As far as possible. Make it intensive, make it as widespread as possible. And don't do a thesis, not at MTech level, okay? Do a project, okay? A design project. All this will make it easier for all the questions which have been raised, for people to get absorbed, okay? And, okay, final, slightly more controversial thing. Anyone doing a PhD should have few years of work experience, engineering work experience, okay? That will change the whole game.
So, yeah, we'll make it
Very
as...
quick one.
Yeah, sure.
First thing, if you have done a PhD or during the PhD, we should start respecting a closed form solutions to check our results. And that is a very big skill set missing with the young people working with us. Everybody relies on Plaxis or Strad or Sophistic. There are 20 softwares, you know. But once I say why it is like that, even for a tunnels, you know, just it's a very simple formula to what is the hoop stress. But people say साहब Plaxis से ये आ रहा है और Place 2 से ये आ रहा है और साहब उसमें wedge action था, सर इसको रैप रिजल्ट मैच कराने के लिए हम इसका C0 कर देते हैं. So now this is what we are. Basically, if we start doing that, you know, we will completely transform these things. And then you will say, if somebody comes to me, सर कोई बात नहीं आपके लड़के काम कर रहे हैं ना, मैं इनके साथ बैठ के इनका चेक कर दूंगा, हैंड कैलकुलेशन करके मैच करा दूंगा, I will get him a job now. Come to that level. See where fundamentally we got lost. I and Vedpal, you know, he's head of Geotech. We often talk about, sir basic connect ही नहीं है, पता नहीं क्या कर रहा है. इसको आर्किमिडीज प्रिंसिपल नहीं मालूम है, ठीक है, और ये कहता है कि जी वो फ्लोटेशन में इतनी पाइल डाल देनी है. So all these things fundamentally, you know, somehow we have lost.
Okay, so this one last.
Quickly, I have 2 points. So actually, regarding the skill set, I can tell 2-3 things quickly. So actually, what is happening is that when you are getting a problem, the most important thing is generate the options. Don't go to solution. First, you have to generate the different options and take the best solution out of it. Actually, when we are in this will come by experience only. It will take little bit, definitely these doctorate students, they are easily adapt in short period of time, but it needs minimum experience. And one another difference is the business communication point of view. When you are dropping an email to X or Y, to whom you are writing, and what you are writing, what you don't have to write. So these things also will come from a practical experience point of view only. Because something you never learn. Yeah. Then when you are a MTech, when you are a student, whatever you do, when you are a student, actually you work alone. But the thing is that when you are in a real-time field, it will be like a collaboration, or it's a collaboration approach. It means it is a teamwork. So basically how to work in a team, that you have to understand. Then again, site-based experience, that also will come from practical point of view. So whatever be the qualifications are there, some minimum 1 year experience is required for a transition. That's it.
Thank you. So you have a question related to this one, or what I was thinking, like we'll also go through this question and at the end we'll take.
I will be asking on that same question.
So then we'll start this question.
Yeah, so my question would be to Sri Partha Sarthi Reddy ji regarding the policy side. So the government spends a lot of money in providing scholarship to masters and PhD students. And as Dr. Nishit also mentioned, and these students, there is no mechanism to observe these students in government. For example, the minimum qualification that is needed is the bachelor's degree. And in fact, many of these technical teams that we have, the government teams, people have no experience in terms of the engineering. Like we just had a meeting with NHAI, the highest qualification was the bachelor's degree, and then they went through IES and whatnot. And then as Dr. Nishit also mentioned, when we talk about bidding, we go for the lowest bid. Why don't we have a mechanism that we test the company based on the number of qualification of the employees they have? So what is government doing in terms of bringing these big policy changes? You are giving money to graduate students, but then you don't have any mechanism to absorb them. And that is creating a big problem. And I hope that some policy intervention, like as we are mentioning here, can go into the government. They make that policy, and then this industry will get forced that they need to hire qualified people. So I would like to have your response to this.
See, when there are two aspects. One is recruitment by the government. So whatever the, like you talked about NHI, the entry level is the minimum qualification that they look at is BTech, civil engineering, BTech electrical engineering. So they take the civil engineering, and based on the area of their expertise, they may look for the additional qualification. But you touched upon the quality-based selection. Okay, for example, if you look for the consultants, okay, there is something called QCBS, quality cum cost-based selection. Okay, so there the selection, the weightage is more for the quality. Okay, two bidders are participating, two consultants, I call two bidders. Two bidders are participating. If the one bidder is providing the key personnel, having more expertise as compared to the other bidders. So key personnel generally they get 70 to 80% weightage, cost only get 20 to 30% weightage in QCBS. Where in the consultant selection that approach is already there, that is being followed also QCBS. Even when it comes to the works in 2021 or 22, this has been brought into the works, giving weightage to the company in critical projects. If the project to be delivered requires the capacity of the entity to also be taken into account. For any infrastructure project, the bidding criteria is very clear that you have a technical capacity requirement. Generally, in the last 5 years, you should have handled twice the size of the projects that you have handled. That technical capacity, financial capacity in terms of network. These criteria are there. So it is not that the bidders who are getting eligible to the infrastructure projects doesn't have any experience. It's not right to say that. So they are being, their eligibility criteria requires them to have proper technical capacity and financial capacity. Even look at the highway sector. If there is a bridge which is an important bridge, okay, an additional criteria of experience in the bridge is also added. The bidder should have the experience in undertaking the bridge. Okay, if the bridge is of 100 meters length, he doesn't have to have an experience of building 100 meters bridge. They may say 50 meters length or 20 meters length. In tunnel also, if he has to build a tunnel of 1 kilometer tunnel, the experience criteria could have been that 500 meters or 300 meters tunnel experience you should have handled. So this specific job, specific requirements, technical qualification requirements are built in the tender documents. Okay. So this technical eligibility, financial eligibility criteria are very clear. Okay, when you come to the even more than that, okay, if there is a project which is specialized in nature, which requires more competency on the part of the bidder, okay, in those cases, the quality element also has been brought in, that GFR in 2021, it has been brought in. I think I can share that with you and you can have a look at it. Thank you.
Yeah, with respect to this
infrastructure projects, in the criteria, if somebody fails to execute a project, he is debarred. Okay, so that way, generally, if somebody meets the qualification criteria, eligibility criteria, then L1 there should not be any issue.
The quality is linked to the degree. The employers who have degrees.
No, when it comes.
Minimum MTech, you should have, like say geotechnical, you should have at least 2 people or 5 people or whatever, depending on the project. You should have so many graduate engineers.
Coming to a specific question, we have actually implemented a system for consultants, IT consultants, where we are giving extra points for a PhD, extra points for master, extra points for this. And finally, it was for the QCK system, so many marks for technical, so many marks for press. So it was not the lowest everyone. But this was done only for consultants. Now for works, it's relatively recent. I'm not aware of it.
Yeah, the first point I would like to talk related to the skill set. I think, yeah, as all the experts have said and on the floor also, one is that the skill set what is required for industry, I think it has to be imbibed into the curriculum and then we have to make them industry ready. That we keep discussing that. But then the students' mindset and interest also in recent times, everybody wants computer science branch and IT branch, finally we end up into other branches. Like I always tell, okay, you love and get married, otherwise you start love whom you get married, right? But that is also, the challenge, current challenge is, I end up in civil engineering, but I started loving it. So, but that doesn't happen immediately for many of the current generation students. That is where the crux comes, how strong the fundamental understanding is there along with the skill set. So only when you learn with love, it stays in your brain and mind longer actually. So this is my humble suggestion to the floor that, we should learn with love actually. So then we will be able to meet the expectation of the industry. That is first point. Then the other point is with respect to policy, because, the salary difference at the entry level between the IT sector and the core engineering sector. So that is one of the reasons also why students actually lack motivation to pursue or with love the core engineering subjects, including civil engineering. So maybe the government has norms for having a minimum salary for a daily wage labor, unskilled, semi-skilled, skill. I don't know, we have any such norm other than government jobs which have a clearly defined pay scale. In private sector, this is the minimum salary that has to be given for a BTech guy, freshers and with some experience. Similarly, MTech and then PhD. If you have some sort of broad guidelines or norms, prescribed by government, of course the skill set have to be met.
So therefore, that kind of policy may help in actually, and also the career growth perspective which Professor Datta has highlighted. That is very important, I think. Because, the career growth in core sectors with experience goes exponentially high. That has to be kind of, even projected to the students actually. I mean, that is very important. Many of them, they don't know also where will I stand in 5 years experience, 10-year experience actually. Those growth perspectives also have to be kind of, told to the students community. I mean, we have some initiative which I'll talk about it later. But can government do something fixing some minimum pay salary by the private party? And nowadays with RTGS and other things, it is ensured to monitor also, because maybe norms are there, but sometimes difficult to monitor in those days, but today's scenario, it's definitely possible.
Okay, I'm sorry, I think we have to stop this. I know it is going very interestingly, it's very difficult to stop, I completely understand. See.
Okay. Please refer to Department of Expenditure Guideline 2910-2021 and 2910-2021, 29th October 2021 and 1st November 2023 with regard to QCBS for works.
Thank you. So, I would like to tell you, we are going to continue this discussion. Trust me, I mean, this is the first beginning of the endless journey, sir, I think. Beginning of the, so, yeah, kind of, yeah.
Major delay, sorry, I'm taking some more time. Okay. So, looking at this intervention in delays in infrastructure projects, okay, there are two elements that we look at it. One is delays in infrastructure projects is they lead to how it is relevant to the geotech. I'm linking to the geotech. Okay, so they lead to the time overrun, cost overrun. Once there is a time overrun, there is a cost overrun. Okay, time overrun has number of elements to it. One is land acquisition, and how geotech engineers can lead to reduction in the time on cost overrun is in the design element. Okay, for example, in a normal item rate contracts, there are three modes of when you enter into the field. You have generally three modes of contracts are followed. One is item rate contract, another is EPC contract, another is BOT contracts. Okay, in item rate contract, as you go on executing the contract, if something design changes have to be done, the risk is on the part of the government. Government takes the burden and it changes the design and it pays for it. But in EPC and PPP, BOT mode, the risk is on the part of the contractor. It's a concessionaire. Concessionaire has to absorb that risk. When he is bidding for the project, he has to take that risk in design. Okay. So how geotech? So if the concessionaire contractor sees more risk element, or if he cannot visualize the risk element in terms of the geotech, then he will add it into the bid. So the actual cost will be high for the government. So as to how can we address that uncertainty? Can we address that uncertainty so that the technology can bring some level of certainty to the bidders when they are bidding for the project? Okay, when for example, when high-speed rail is constructed, the sampling system, okay, they may be taking a sample of every 100 meters, but the foundation you have to take every 20 meters. How can I reduce that uncertainty? When he goes and go to the foundation for 20 meters, so that soil may be different and he may have to incur additional costs. How can I reduce that uncertainty? Is there any technology that can address this uncertainty? I think this is one area we can reduce these delays in the projects insofar as geotech is concerned. Thank you.
Thank you. So there are some more questions from my students. I think we'll take it up later. I'm sorry, man. Extremely sorry. We'll definitely, this is not going to be the end. We're going to invite these experts through the student body that is going to be formed right now. So please hold on your questions for some time. Yeah. So, but yeah, I would like to take this opportunity to thank all the speakers for their valuable time and the suggestions and the inputs. It was fruitful discussion for sure. And once again, thanks, and please join me to give a round of applause to the speakers.
So while we are taking the photos, I would like to invite Professor Tanushree Chakravarti to hand over a small memento to Sri Partha Sarthi Reddy Chevuru for gracing this occasion. Sir, thoda. Sir, Ravi Sundar, you can just take up. We have already given the memento. बीच में आ जाइए. I would now like to invite Professor Bappaditya Manna to hand over a small memento to Sri Govindraj ji. And then finally, I would like to invite Professor Debayan Bhattacharya to hand over a small memento to Dr. Atul Nanda. So it was a great and panel discussion, a very long panel discussion, and this conversation will keep on continuing. We are in the phase of revising our curriculum, and we are going to bring some of the changes, and we will need these conversations to go on. And along the same lines, I would like to invite Professor Ayothi Raman to launch the new initiative that we are initiating on the eve of this occasion. So, Professor Ayothi Raman, please.
Yeah, very good afternoon, everyone. Yeah, so we have been holding you longer, right? So I think we had a wonderful panel discussion, right? The bridging the gap between industry and academia. And I think this discussion always comes. I think I remember as a PhD student, I was in a conference at the University of California, Berkeley, and there was a session, panel discussion happening on the same topic, bridging the gap between academia and industry. And it's not going to be an ending issue. It will keep coming because the technology evolves, and it is a continuous process. And then there will be a gap trying to develop and become wider. But we should all collectively try to keep the gap closer and closer and bridge it as close to as possible, actually. And this initiative, what we have, the Geotechnical graduate student group at IIT Delhi, is an attempt towards that, actually. Because we know the stakeholders are, we academia, we work, and industry people, they work together, for a common problem of community, societal problem. So we all have to work together. And that is where, this graduate group have been initiated. And the main objective is we actually invite industry people and have interaction frequently under this umbrella. So that's the whole motive, actually. And we keep learning what is the societal need, what industry, how it is working, and how we can learn from industry mutually, and then, then they learn from us. So there is always a mutual exchange of information and knowledge. And finally, we collectively work to solve the societal problems, for a common cause, actually. So that's the way this initiative has been taken. And we are very glad from the, Geotechnical Engineering Group of IIT Delhi to launch this Geotechnical graduate student group at IIT Delhi, what we shortly call G2 SG IIT Delhi. So there was a nomination or election, and this year we have a team which have been already, anonymously selected. Deepak Kumar Haridwal, congratulations to him. He is elected as a president. And Amrisha Khandelwal, she will be the treasurer. Congratulations. Please join the stage. And Miss Vandana, she will be the seminar coordinator. And Saurav Nandwal, he is the outreach coordinator. Yes. And Himanshu Saurav, he will be contributing as a public relation coordinator. And my dear colleague, Dr. Sumit Sinha, he is the faculty advisor. So, please. So, give them the big round of applause, and we look forward to have a, wonderful. Yeah, great. Come. Yes. So they were perfect number of chairs. Great. So congratulations. We look forward to your great contribution towards this good initiative. Now I invite Deepak Kumar to say what are the activities they have actually planned quickly. Yeah. Yes. Thank you.
Thank you, sir. Very good afternoon to everyone. Myself, Deepak Haridwal. I'm a research scholar in Civil Engineering Department. First of all, I would like to welcome all the faculty members, industry professionals, students for giving their valuable time to make this event a grand success. I'm very excited to give you a brief overview about the group, that what our plans and what our missions. So basically, we just want to make a platform so that our students can have enough ideas and they can have just want to know that what are their plans and what are the industry actually need. So based on this, we have actually planned a lot of initiatives that we are planning to have some regular seminars, which includes professionals from the different types of industry, so that they can get to know what type of demand actually they're having and they can increase their knowledge. As well as we are also planning to have some field trips so that they can have an idea that what are the actual field side conditions and what are the on-site conditions they are actually having. And we also plan to have some outreach plans so that which also include some workshop, so that whatever the new types of softwares as well as the new types of cutting edge technologies that are being widely adopted, the students can get to know. This also includes some social events so that we can, as a faculties as well as students, so we can get to know and a strong bond together. As a team, we can grow all together. This also includes some collaboration to the academics also, as well as the industries. In the end, I would like to very thrilled to announce our flagship event, that is basically the annual conclave, which includes an interaction between industry as well as academia, where the students are given opportunity to directly showcase their work in the front of academics as well as the industry professionals, so that it will help them to increase their outreach capacity. This will also help the other students to get to know that what type of work that is being going throughout the department, so that they can showcase their work. This particular conclave also includes some podium presentation as well as poster presentation, so that it might help the students so that they can increase their confidence also, and they can show their work, and which would ultimately might help them to increase their outreach. So in the end, I would like to thank once again all of you, and we are looking forward positively to the next event that is being organized by the Geotechnical Graduate Student Group. Thank you, everyone.
So thank you, Deepak. So we are excited about this group, and the activities of this group will start early next year. The next 3 months we are going to brainstorm, and maybe we'll have one activity or something. So wow, it was an incredible day. We have exceeded 2 hours, so that's fine. But it was really exciting to hear from great speakers, and we had a great panel discussion. First and foremost, I would like to extend my heartfelt thanks to all the distinguished speakers for accepting our invitation and presenting at this event in a short notice. I would like to express my gratitude to Mr. Venkatesh, who reminded us about this occasion and actually came forward with a small plan about this event, which we later modified it and made this as a big event. And of course, many thanks to our faculty members and all of you, the students, for your invaluable support and making this event a success. Now, this is not the end. We have just finished 100 years, and we are moving towards the next 100 years of geotechnical engineering. And at IIT Delhi, I'm sure we all are thrilled to be part of this journey, and we want to take the lead forward. On this note, I would finally also like to extend an invite to all of you to the next year. We are going to celebrate Diamond Jubilee. We will celebrate the 60 years of geotechnical engineering at IIT Delhi. And this would be our next big event that is coming next year. Likely it we will merge with the annual conclave, so we'll see that. With that, I would like to formally close this event, and I invite all of you to come on the stage and have a group photo. Thank you. Acha, haan. So a quick announcement, we are also ordering food. We know it's late, you have all missed your lunch. There is some food already there, and we are also ordering some more food. So don't worry, you will get. Yes. Yes. So by the time we take the group photo and you eat some snacks, some more food will come. So don't worry. Okay, so can we take a group photo? Let's come. I'll request all the faculty, please come on the stage. Huh?
ये लोग अड़ेंगे आगे आ रहे हैं
अनीता अरे तू वैसे में दिखेगी
वो हो गया है
Just one of our colleagues is so humble and he's not taking any credit, who is just standing next to me. This event is so successful, like, yeah, all of us have contributed, but he has the Delta extra contribution. Okay? And so I think that is what I want to say. And then thanks for reminding us to Venkatesh. And that's how. And one thing that I want to share, actually my colleagues are also under a lot of pressure because we have to make the presentation. So one of the colleagues did presentation in the night also actually. And Raat Subhata, and one colleague came in the morning and took around 13 minutes to give his history of curricula. And he was given very short duration, and he was some. Excellent presentation. Is it? Okay, I thought I was the one who gave the excellent presentation. But okay. But thank you. And Manna sir, thanks for walking through your research. It was amazing, trust me. And now this should lead to some new ideas, and we should meet regularly. Especially we can call them and complete that questions what we have. Okay.
अच्छा दीपक, वो नंबर ऑफ प्लेट्स गिनते हैं, तो आप प्लेट जितना है उतना ही लेना, नहीं तो देन दे विल चार्ज मोर, क्योंकि ऐसे भी तो आ रहा है बाहर से। व्हाट आर यू?
बर्गर मंगा रहे हैं सर।
हाँ हाँ, तो वो देख लो किसको नॉन वेज चाहिए, किसको वेज चाहिए।
वेज ही है, इतना सबको कस्टमाइज।
हाँ ठीक है, फिर
सबको वेज ही है क्योंकि वेज हर कोई खा लेगा।
ठीक है, तब तो सही है। चलो, आई थिंक दैट वाज अ ग्रेट इवेंट।
यस सर, कांग्रेचुलेशंस सर फॉर योर फर्स्ट इवेंट।
हाँ, डायरीज तो दे दिए ना, एक ही बचा ना बोलो।
सर वो एक एक्सचेंज वो उसमें जो गोल्डन है उसका सर वो उसकी बाइंडिंग पड़ी है।
You want to be unique as a president. Yeah, ये भी हो गया ना। So I said you keep it like in your cabin or you can give all.
Done?